Your lifestyle.
Good evening, ladies and gentlemen. Welcome to another session of Fluid Power Professional Day celebration. We call it the FPTS event. We are starting off the event today evening with a lighting of a lamp, followed by the Ganesh Vandana.
गणेशानाय भालचन्द्राय श्रीगणेशाय धीमहि श्रीगणेशाय वक्रतुण्डाय गौरीतनयाय धीमहि गणेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
Okay, we move on with the FEPD program. To start on with, I request our President Hemant to address the gathering.
Thank you, Suresh.
Good evening, ladies and gentlemen, industrial, institutional, and individual members of FPSI, the 20 student chapters and its students across the country, the Board of Advisors of the FPSI Council, members of the FPSI Council, the FPSI Secretariat, friends from the Fluid Power Fraternity who have joined us online. As President of the Fluid Power Society of India, it is my great pleasure to extend a warm welcome to you all to the annual Fluid Power Professionals Day celebrations. June 19th is a day to recognize for all who work in the fluid power industry. Internationally, the fluid power community celebrates 19th of June, that is the birthday of Blaise Pascal, considered to be the father of fluid power, every year as the Fluid Power Professionals Day. Industry stalwarts, members of the Fluid Power Society of India and the Fluid Power Fraternity gather on this occasion every year to celebrate this event. On this occasion, we recognize and honor eminent industry and academia persons for their contribution to fluid power industry with the Pascal Award. Today we have the Pascal Award ceremony where we will be honoring two stalwarts from the Indian fluid power industry. Dr. S. Karunanidhi, Director of the Control Actuation Systems Laboratory, DRDO, Hyderabad, and our dear founding member and Board of Advisor, late Mr. M.S. Yoga Narasimha. Mr. M.S. Yoga Narasimha, as he was fondly called as MSY, was the guiding light and passionate advisor to the FPSI Council. He was a mentor to many in the Council. FPSI salutes this noble soul for his enormous contribution to the society over the last 47 years. He will be dearly missed by FPSI. FPSI has been privileged and honored to have Pascal awardees such as Mr. Venkatramaya, former Joint Director, CMTI, Dr. K. Apraman, former Chairman and MD, DML, Mr. C.P. Rangachar, MD, UCAN, Dr. B.V.A. Rao, NIAS, Mr. Desikan, MD, Hydroline Products, Mr. G.L. Soda, MD, Priac, and Mr. Prahalad Dabolkar, MD, Tucson Hydraulics. We recognize the best project presented by students from the various engineering colleges during the FPPD celebrations. But due to the pandemic, we could not hold a physical event, and work is on to conceptualize and conduct an online competition to identify the most innovative and beneficial project using fluid power. Every year, we have the FPPD celebration as part of FPTS, and I'm pleased to inform that we were able to conduct FPTS on June 17th and 18th from 4 different regions, starting with Coimbatore, Pune, Belagavi, and Chennai. Our chapters were fully involved in planning and hosting these events. We had a huge participation and impressive lineup of speakers and papers. For the first time, FPTS was conducted virtually. During this event, we are also proud to have been associated or having the CII and the Association of Equipment Manufacturers USA as supporting organization for FPTS 2021. FPSI, established in 1973, continues to strive for excellence in education, research, and technological advancements in the field of fluid power. Besides the registered office in Bangalore, the regional chapters at Chennai, Pune, Coimbatore, and now Belagavi are equally active in spreading the knowledge of fluid power. It has more than 20 chapters across the country. We also have a panel discussion with captains of the industry on the topic, how can we make India one of the top 5 manufacturing hubs in the world for fluid power products. I am glad to welcome our panelists, Mr. M. Sitapati Rao, MD HiCom Engineering, Mr. Upinder Razdan, MD Danfoss Power Solutions, Mr. Rashmikant Joshi, MD Festo India, Mr. Shandar Alam, MD Parker Hannafin India, Dr. Deepak Maiti, President Indian Operations, Cimerix, and Mr. Sheshnath, who would be our moderator for this session, MD and CEO of Valve Fluid Power India. We will also have a session by the International Fluid Power Society, represented by Ms. Donna Pollander, Executive Director, IFPS. I welcome Dr. Karunanidhi, Director of the Control Actuation Systems Laboratory, DRDO, Hyderabad, Mr. Vikram Sinha, son of late Mr. M.S. Yoga Narasimha, Dr. S. Prasanna Kumar, and all our panelists. I would like to express our sincere thanks to our platinum sponsors, Dynamatic Technologies, UCAN, Valvoil, Argo Itos, Permco, Boss, Danfoss, and gold sponsors, Wipro, Tucson Hydro Controls, Hydraco, MP Filtri, Larsen & Toubro, and Cimerix. Sincere thanks to all our sponsors, without which this event wouldn't have been possible. FPSI is honored by the presence of all our esteemed guests, and I'm sure everybody is waiting eagerly to hear from them. I welcome all our participants once again to this celebration. Thank you.
Thanks, Hemant, for giving a detailed brief on the event for the day. Next, we move on to the inaugural speech, which is by Dr. S. Prasanna Kumar. I'd like to give you a brief about Dr. Prasanna Kumar. We, in our fluid power fraternity, call him as doctor. He's got about 36 years of experience in this field of fluid power. Member of various professional bodies like Institute of Engineers, Institute of Welding, Institute of Non-Destructive Testing. He is also been teaching people in the UG and postgraduate programs, and conducting researches in the area of fracture mechanics. He was deputed to Germany in this regard for higher studies, and he obtained a doctorate degree in testing of welding joints. After about 13 years in the field of teaching, research and consultancy, Doctor moved back to India and joined Larsen & Toubro Bangalore Works, the earth moving and construction company. He's been on various capacities, areas of welding, quality control, purchase, exports, imports, and material management. Then on, he went to head the hydraulic factory and managing the hydraulic operations. And later, he finally moved on to the position of chief executive at L&T Case Equipment, Pithampur. Doctor is still very actively involved. He is an advisor in the FPSI Society. He is also working as a consultant to the mobile, ancillary, and fertilizer and refinery companies in the area of metallurgy, welding, and failures. Over to Doctor to give the inaugural speech. Doctor, you're muted. Can you unmute, please?
Coming. Thank you, Suresh. It is nice of you to introduce me as a multifaceted personality. It is so because today we require that multifaceted personality, because we are going to talk about Bly's fiscal and also hydraulics, which is having multi-functionality. Okay, let me start. Respected President and fellow professionals, I am delighted and honored to inaugurate the Fluid Power Professionals Day at Fluid Power Society of India on this 19th day of June 2021. As President told, internationally, the Fluid Power community celebrates this day as Fluid Power Professionals Day, as the founder of hydraulics, to say, Blaise Pascal was born, the French physicist and mathematician, was born on 19th of June 1623. I'm not going to talk about his theories and practices and so on, or I won't recite the Pascal law. Either I will make mistake or I will be carrying the coal to the Newcastle. I will differ. When we are celebrating the Fluid Power Professionals Day, we have to analyze what entails a fluid power professional to perform. My goodness. If he has to perform, what makes him perform? His competence, of course. What is his competence? It is a combination of knowledge and skills. And where does he get the knowledge? From his education. And where do he get his skills? During training at the present employment. So when he has to perform very efficiently, he must have enough knowledge and enough skills. Then fluid power community will grow and fluid power will grow. So now, when we are talking of this, we come to the point where we have to have three phases we have to describe and then find out a solution so that what FPSA can do and contribute. What are the three phases? Phase one, education for a fluid power professional. Two, a continuous training when he is under employment. And three, there we may not have much of a control, but what he will do in future, he is worried. It is past, present, and future we have to worry. The past is education, present is the employment. But when he is doing that very nicely, he is contributing with his competence in the factory or entity he is there. He is also worried what will be the future. So he has to innovate. He has to see that he keeps pace with that. So for that, we have to also tell him what will be the future of fluid power for him to contribute. So now we have to concentrate a little bit on the three phases. Education phase one, phase two, employment, phase three, future of fluid power. It looks like a very, very big topic. But our analysis of the aspects of education, we are coming to a shocking conclusion that there is no systematic coverage of what is to be imparted. This is what happens actually. Thanks to my colleague Dr. Singaparmal, he has sent a recent report of a German fluid power industry as well as VDMA. What they did was, they had a commission, a Fluid Power Association has commissioned a study. In the what is happening, the type of fluid power lectures that are going on in Baden-Württemberg were analyzed. What they happened? The study confirmed that they recognized the difficulty in identifying and differentiating the various courses offered, as there is no standard description and no designation of content and lectures precisely. It is very shocking. That is from the German fluid power industry. It's a recent report. When we are going a little bit more, and not only the curriculum, the regular curriculum, the curriculum always contains what is known as electives. Then it is a very dangerous topic. Electives have got so many topics they give, and it becomes a rat race. Whichever elective has got more number of students, it thrives and it gives life, but which has got less number of students, it is not taught. Otherwise, Even though the curriculum or syllabus may be available in various universities on certain topics, including fluid power, they may be offered, but they may not have been taught. So this is one. The similar one experience also noted by the meeting of finding of a study of NFPA, National Fluid Power Association of USA. They also found that educated workforce is necessary, but there is a continuous issue in that. They are not getting it. Meanwhile, I just want to intersperse a recent report by United States of American Technical Committee. We are going to have a similar, what you call, demand by US as they had 2 decades back for the software engineers. What the study has told, a riveted study has told is, for the multidisciplinary actions of fluid power, which is used from garbage truck to, say, satellites, they found that there are not many takers. They may have to import lot of trained people in the fluid power for their sustenance of these frontier areas. So now we have got two things we have studied already, German fluid power as well as NFPA US. Both are telling there is something lacking in the education and we have to, strengthen the curriculum. A few years back, in our own Fluid Power Society of India, our past president, Sri Sitapati Rao, very nicely identified the similar thing, and he started about 10 years back how to have, he had discussions with the university vice chancellors and started various studies on various, what type of curriculum they must have, a syllabus must have, and also started having various FPSA chapters. This is a very pioneering work so far as Fluid Power Society of India is concerned. And now we are talking of education, and then where we have come to this point that education requires our attention. Why I am telling all this again and again is the future we are going to do. The third phrase is future. Future of fluid power rests with the talented, committed, trained fluid power manpower, fluid power professional. So naturally, I have to insist again and again on this Fluid Power Professionals Day, what is required for us. So the second one is about the training or the present employment, what is the skills they are getting. For this, a continuous education program is necessary. In this also, I commend that Fluid Power Society of India has started a good exercise. One is training the trainers for the program, as well as having the teaching faculty having a refresher program, and also for the industries, a training courses to be offered, we are seriously discussing. This has to be concentrated. When we have already seen the German as well as US, as well as there was a study from British FOA also, that manpower or the workforce will be the future deciding factor for the growth of the fluid power industry. Then third phase, when we are coming, what is the future of fluid power? It's a very nice question, metaphoric question, and so on and so forth. One thing we must understand that fluid power is not a what you call industry began yesterday. It was 400 years back. Blaise Pascal paved the way for it. So it is a mature industry. So when a mature industry is growing, there are a lot of opportunities for the multidisciplinary actions. That is what is happening with fluid power. Why we are talking of earlier the education as well as continuing education and training is that we must recognize that fluid power is a multidisciplinary syllabus, multidisciplinary action, multidisciplinary workforce. That is exactly the problem. We cannot go like one group saying that this is the engine, this is the way we have to do. In fluid power, they are in automation, robotics, and so on and so forth. When somebody asks what is fluid power, one of the recent surveys they told, many whatever immediately comes to mind, they say, what is fluid power? A group of fellows told, no, it is IoT, Internet of Things, that is going to decide the fluid power. Another fellow told, no, it is a digitalization that is going to be a future of fluid power. And third fellow told, it is going to be from nano robots we are going to control. In this occasion, I will just tell, I was a what do you call, alumni of Institute of Science, and I had recently, about 5 years back, arranged a seminar on nanomaterials, along with Institute of Science and Institute of Engineers. When I had a discussion with the nano lab at Institute of Science, the beautiful nanomaterials and also everything was there. But one of the things which I can tell, as it is not a very confidential or patented one, they were also doing on the nano robots to send through the bloodstream so that so many things can be operated or the pathway can be removed, cleaned and so on and so forth. So nano robots. At the time when we were discussing, three of us, we also told why not nano robots type of thing in hydraulics also, in fluid power also, because just like our body, the blood is flowing, in a machine, in the fluid power, hydraulic flow, hydraulic oil flows through everything. Whatever we do for the blood, we can also do through oil. So this was done, and actually there were experiments over for 3 or 4 years, sending certain changed oil configuration additives so that they can remove certain blocks in the walls and so on. But unfortunately, it failed. But there are certain research going on which is to be patented that hydraulic oil also will have something like a whatever blood circulation. We will have also in future nano robots going inside the fluid, hydraulic circuit and repairing so many things. So now the future is so much that when I am talking of nano robots, you can see that it is a question of whether it is not only IoT, it is automation, robotics, and earlier Dr. Singaparmal of IIT will say it is mechatronics which is driving the fluid power. So it can be mechatronics, it can be robotization, it can be nano robots to that extent. All these things come to the future. That means the future of fluid power is also multidisciplinary. Just like French physicist turned mathematician, turns inventor, Blaise Pascal, fluid power also is a multidiscipline topic. That is the one which is a challenge. It is not necessary that only an electrical engineer or a mechanical engineer are there. We must have enough courses, additional courses in fluid power imparted to the engineering graduates, just like they also go to software and then do a lot of work. But there is basic engineering. For basic engineer, we must impart specialization in fluid power in colleges as well as during continuous education. In the continuing education, one was very clear that when the continuing education is done, people will be interested because he is worried about the candidate will be worried about his future. So other than present employment, he want to migrate. I would say that we must actually support the migration by giving a certification program. When during continuous education program, if they have got certification given, the certification enables him not only to perform in his own factory or industry or entity, but he can also migrate to various places. And that is the way the industry has to grow. We cannot have only, like in the earlier Hindu marriages, only uncles and this one nieces to be married. It has to be outside the thing. So if he is trained in one industry, we can do another industry. So now we have seen that the whole course is happening like that. 3 phases I have covered for the fluid power professional as a center stage. We must see that education is streamlined. We must see that continuous education is important. We must see that for when the certification programs are done. And we must see that we have to contribute by innovative methods, creative methods to have a fluid power, having a discussion and dialogue with other disciplines so that it can grow. So with this, I declare the Fluid Power Professionals Day open. Thank you. Thank you, gentlemen.
Thanks, Doctor. Thanks for the inauguration of the event and giving us an insight to what's today and how we need to look at tomorrow for the fluid power industry. Now it's time for us all to award some of the eminent personality, both in the academia as well as in the professional environment. We go on first to talk about Dr. S. Karunanidhi, who is the first awardee of today's event. Let me give you a small brief about him. There are a lot of things about him, but we have tried to put together his credentials and give you a detail. Dr. Karunanidhi is the director of the Control Actuation System Laboratory Research Center, DRDO, Hyderabad. He is among the key scientists responsible for design, development, and realization of control actuation system and components for the missile programs. Typically, we're talking Prithvi, Agni, A4, Nishant, PSLV, GSLV, and other variants of the same. He obtained his MTech Mechanical Engineering in 1995 and PhD in 2010 from IIT Chennai. He has made significant R&D contribution in the engineering science, particularly in the area of indigenization, development of critical aerospace components for strategic aerospace systems of the country. He is credited with the development of aerospace grade electro-hydraulic servo valve, we call it EHSV, based on the Missile Technology Control Regime, MTCR, for the first time in the country for all national aerospace programs. These EHSVs have been successfully used in some of the projects that I talked, that is the Prithvi and its variant, Agni and its variant, PSLV and GSLV. His latest contribution is the hydraulic control component used in ASAT, Mission Shakti. He has also got patent for this. His other indigenization, defense, product design and development activities include high pressure, quick response solenoid valves for all variants of Agni, Prithvi, K4, Akash missile programs, and Nishant pneumatic control systems for Project Akash, and jet pipe servo valve for Agni program. He has initiated also work on futuristic technology like smart actuators, high frequency actuation system, high pressure aerospace products and system. He is also recognized. He has also released smart actuator integrated servo valve whose frequency response is higher than the conventional valve, which has produced aerospace grade EHSVs we talked about earlier of various specification. These are all coming under the government owned company operated program called GOCO concept for the applications in missile and aerospace program. He has made significant contribution in the area of precision engineering, instrumentation and control, fluid power, mechatronics and system simulation. He has to his credit several highly cited research papers and technical reports in these areas. He is regular reviewer for international journals like Sensors and Actuators, Precision Engineering. He jointly owns 2 patents with IIT Chennai. He has been associated with national and international professional bodies and organized many symposia, conferences, and workshops. He has earned many awards like the Agni Award from the Ministry of Defense in 2008 and 2009 for the excellence in self-reliance. He's also got Dr. V.M. Gadge Award for Excellence in 2008 and Scientist of the Year Award for the year 2006 for his contribution on the actuation and components for various programs like the Akash Nag, Neek Prithvi, and other DRDO awards. In recognition of the research efforts, achievements, and contribution to national technology excellence of Dr. S. Karunanidhi, the Fluid Power Society of India is pleased to confer the Pascal Award 2021 on Dr. S. Karunanidhi. Congratulations, sir. We are really honored to have you here and having such a vast experience and so much of pattern behind you. It's a pleasure for us to have you here, and we would like you to say a few words in this.
I have some presentation on what we have done last 20 years. Dr. Kalam was initiated this overall things. When he started, because of our advisor told correctly that the education, the our so-called educator will tell, because when you tell the great things, they will tell making fun of us. Because our education made our professional as a very complex people, not a simple people. Simple person will make everything complex to simple. They are called scholars. So that is what we are facing. When we started this Saroval, Dr. Kalam told, right, it is 90s, 95, 96. I will give you 100 crore rupees. Now it is more than 20,000 crore. I will give 100 crore rupees, then you develop it. Then I told I am very young person. No, I am seeing you last 5-6 years. What is your capability? I know. And because of his thing only, this has come in our country and is flying in all the program. We are second or third in the Saroval in the world in aerospace applications. That is what I will always tell people, that we have to integrate our education system with in our science and technology with patriotism. You see, for us, what we need only 2 chapati. For that, you will get a lot of energy. No, you should think very, very big. So our country is great. Of course, now we have very good leadership in the center. Because of that reason, we have to do indigenization because we cannot import now. I will always tell people that at least once in 10 years, America should do ban. Because always the high technology is, yes, because we are innovative people. We are born in the Bharat. Bharat means what? Bhava, Raga, Tala. It's a vibrant country. Because of this modern education, we have become lazy. Modern education, because we are from ancient or advanced education, we come down to modern education. So anyway, I will give a brief about what we have done in the in our lab, and not only that, all education institute like IIT and all. And at the outset, first of all, I have to thank the esteemed society, that FPSI, for honoring me, and it made me very humble. And I want to show my gratitude. Gratitude is nothing but great attitude is called gratitude. The attitude should be in the education. That is not there. We have attitude, not aptitude alone. So that is why we are. I want to especially our advisor Prasanna Kumar, Dr. Prasanna Kumar, and our Hemant Kumar. I have to thank them because they talked to me, and my guru, Professor Singh Perumal, because whatever I am, because I'm him only, I'm here. Because I am last 25 years, I'm continuously interacting with him for, he's chair for all our fluid component, all review. He's a chair. So because of him only, we could do, this thing. I'll always believe in one thing: we have to integrate, our all research lab and education institute and industry should go together. And we should not, we have to find the, the positivity of each one's, strength, and we have to see that how to integrate. Who can integrate? Intelligent personality can integrate. That is what we have to understand. We should not differentiate, because you can see that even the, our engineering data. If you want to see that if you are integrating, a lot of noise will be creating. In differentiating, you have to integrate, because that itself showing that in engineering that any analysis, if you are differentiating, it will give a noise, and integrate noise will not be there. And I am going to present, that content is anyway electrohydraulic servo valve, and we are going towards that to whatever integrated in the recent time in the fluid power. That's what I want to just maybe it will take around 10 to 15 minutes, and I will try to connect it. And the electrohydraulic servo valve, we know that this is a servo valve, is an interface between the electrical and the hydraulic parts of the electrohydraulic system. And we can in the missile system we are using in the first time and all our Prithvi missile we are using it, and you can see that where it has used. Otherwise, there to see no. Before seeing. Okay. And you can see the aircraft. Whatever red is given, that is a hydraulic part, and whatever is green is given is a electromechanical. And actuation system we can differentiate with there are three types, that is called pneumatics and electrohydraulics and electromechanical. That means it is a gas, liquid and solid. These three are coming. So in that generally wherever we are using, even the human is I can tell hydraulic system. That's why I would like to connect to the human things. So here we can see that in the aircraft all primary control, secondary control, and you can see landing gear and primary control of rudder and all. They are using hydraulics only. They are trying for any other means of electromechanical and all. They are unable to do it because for long duration they have to live with like a human. They live with hydraulics only. But hydraulics got a lot of other advantages of the stiffness and frequency response, etc. And hydraulic, you can see that electrohydraulic is a simple thing. Three parts are there. One is called torque motor, other one is called hydraulic ambulance. Last one is called that spool valve. And the integration of these three only we are making as a servo valve is so principle is very simple. In the life also principle is simple, but when you are going for technology and then adoption, there only the difficulty will come. And of course we took maybe around 5 to 10 years to understand that technology. Science is not having any border, but technology is having a border. That's why always the Western country they never give any technology to India, because we are untouchable. Always the untouchability is there one form or other. The olden days we told that our science was not given to anybody. Always that is there in materialism. Once you are going to spiritualism, there is nothing like the second one. That is the reason I would like to tell you, we took some time, and when Dr. Kalam is given that time through. That time, he talked to LCA. Kota Harinarana was that time, the program director, and such a project has come the first time in DRDO. We could see that all technology developed, and all the institute like IIT and many industries also participate in this. Finally, we could get what we want, and we have developed around more than 20 different specifications. We can see the type 1, type 2, type 3, the interface, and jet pipe servo valve. That is the jet pipe servo valve is used in all the contamination is a big problem in any hydraulic system. Just now the advisor also told that that the micro nano robot and all we have to go behind that. We have to use it. The contamination is a big problem. That contamination can be solved in the flapper nozzle valve by jet pipe servo valve. That also we have developed. All Airbuses using the jet pipe servo valve because human is involved in that. And we can see wherever we have used all our Agni, Prithvi missile and launch vehicle of PSLV and GSLV. We are giving more than 10 years to our launch vehicle. We have to appreciate, and we have to always think that always our ISRO will use only indigenous thing. So that's why I will always tell people that you have to see that our own product is used in that, because now it is slowly it is coming because of the government policies like that. Once we made in the country, we have to use it in all our systems, in the aerospace system, otherwise also. Now it is flying in that LCA and Kiran, and LCA they ordered now around for 83 aircraft to us. You can see what is the cost, cost benefit. One actuator was importing from MOOC, it is around 1.4 crores. Now we could make it with 40 lakhs. That means 1 crore. That means 30-35% of the cost. Not only that, lot of employment is generated in the country. See, we have to not that money alone. Value we have to find out. It's the cost is not alone. The value because a lot of thousands of people are got the job now. That is one thing, because the last 30 years we are in indigenization of all our aerospace component or missile component, because MTCR, the missile test regime, they are not they are stopped us buying anything from Western country. Because other country also they are giving, American government, this regime is giving in a lot of pressure not to supply to India. So that is the reason we have to do it, and we could save in the money with thousands of crores, not a simple 1 or 2 crores, thousands of crores we could, and lot of industry has come out, in Bangalore and Hyderabad. That is the reason we have to see that everything is done in the country and it should be Swadeshi product. So these are all flying, our Prithvi variant and BrahMos, GTR engine flight control, that also we are making now. Very challenging one, there is no doubt about it. And Israel and aircraft, we can see that Kiran and ALX. Next. I'm going very fast. And the electrohydraulic servo valve, the types, I already told the torque motor. Torque motor, we can see here the flapper and nozzle. The between these two around 30 to 40 microns only. If any contamination is coming, this valve will malfunction. That is the reason we have to see that the practice of fluid power is coming, because fluid power, how to clean room we have to maintain, how to do the maintenance of any fluid power. This should come as a culture. We have to train them. It should come as a culture. Otherwise, it is very difficult for any aerospace actuation system or hydraulic control system. That's why we have to give that training. And now small training we are giving CATD for that hydraulic things and all. We have to see that how we can improve it. And what you are practicing, maybe they are very, very long way, the technology. Now we have to see that how to do it. This is 30-40 micron. Now we can see that jet pipe. In that here you can see the jet pipe, and that there is a standoff distance. There only if any contamination comes, it will stop. It is contamination up to 150 micron. It can sustain. That's why they are using for all this aircraft application. This jet pipe servo. And direct drive valve, but it is little bit highly reliable, but it is very bulky. If the space is not there, it is very difficult to accommodate it. Now this is also going for all our aerospace applications. And you can see jet pipe servo valve at all 380, Airbus 380 they are using in many numbers. Again the rotary, otherwise the direct drive. This is a recent development, around 2008 some paper has come. And but application wise, much publications are not there. This is called rotary, direct drive valve. The rotation will be converted as a linear movement of the spool. And you can see the dynamic and power requirement of any servo valve. And we can see frequency of servo valve, and you can see what is the power. And the hydraulic will come in the middle of that. The right side up, we can see that it is uncontrollable. And below that is called electromechanical and electro-pneumatics. And in between, whatever is coming is a conventional, conventional electrohydraulic control. And you can see that hydrostatic control. That is now they are using many hydrostatic control system. That is a fluid control system in the 380 aircraft. And beyond that, beyond this boundary is called new servo control. That is nothing but high frequency servo valves. Wherever we want to use it, in a very high frequency actuation system, there we can go. That is called smart material, related. Why some material is called smart? It can be used as a actuator and sensor. That is why it is called a smart material. That's why in the human also somebody is a smart mean they have both. They know that things and they will execute also. Those people are called smart people. Not only the theory part of it, we have to see that the execution part of it also. So that's why it's called smart material. Here we are done some work in RCA also. RCA also with magnetostick tube, an actuator. You can see the middle of that roll is magnetostick tube. Nothing. When we are exposing to any magnetic field, it will give a strain, or we can say that a deflection. And this will be around maybe around 1000 to 200 or to 1500 ppm parts per minute. That's why each mm will give 1 micron, and we have to see that how much you want, and you can use it by you can amplify by amplification mechanism also in the cost of some other frequency thing. And this you can see piezoelectric actuator. This is flapper nozzle only. In that we are already assembled and we are performance tested. We can see that piezo actuator and torque motor, that is a conventional thing. And this actuator with the servo valve, you can see that what is its millisecond 0.85 millisecond. Other one is 2.7 millisecond. And actuator level, if you are seeing that 0.4 millisecond, and other one is 1.5 millisecond. And frequency response also it is going beyond 300. Otherwise, it is very difficult to achieve by any other means. This also we are demonstrated. But wherever if they want to use it, then they can see that it can apply. Next is that the big weight is coming in the fluid power. That is called hydrostatic actuation technology. And this technologies can be used in if you need a very high load. And you can see the first thing that is called EHA, that is conventional electrohydraulic actuator. In that valve is used. Because of that valve is used, there is a pressure drop. Due to that, efficiency is less. And EMA now many of our missile system, because of maintenance is more important. So that's the reason they are going for the solid. That means called electromechanical actuation system. Even some place they want to replace like Agni program and all. They are trying to replace this one with EMA for first stage, and not done. But they are thinking that easy to maintain it. You can do that, and we can see that by electronic control in the variable meter. That means brushless motor they are using it, because that is the latest development, and RCA is done not less than 20 different varieties of that. And gear mechanism. Then we are using ball screw or roller screw for rotary motion to linear motion. So number of components are less. That's why they are telling the reliability is better. What the only problem is backlash is one problem in this. But how to address it, we have to see that. And now this conventional electrohydraulic actuation and EMA, we are combining it. That you can see that the gear and other ball screw, this one we are replaced with hydrostatic transmission, hydraulic transmission. That's why this become more simple and minimum number of components. This it is flying in all A380, because they are in the Western country, they started to use it. But when we are asking this one, they are not giving it to us. But we are already started to work on this area. And VSSC also, we are together, we are VSSC also some proto model has come. And now we have to see that how to do it. And in this advantage EHA, we can see the self-contained hydraulic system, because if in any system one is failing, that is a centralized hydraulic system failing, mean all fail. Here not like that. The maintenance time is very less, because when wherever it is failed, we have to see that that only we have to. It's an autonomous thing. That's why we have to just remove it. That's all. So then we can maintenance the time we can reduce it, and it is lightweight and limited contamination and leakage, because it's totally closed at a time and no backlash. That is another big advantage. Maintenance free sealed unit and power on demand. That's why we can save a lot of power. These are the advantage. Now many countries they are working in this area of fluid power and reduced frequency. This is a limitation. Reduced frequency response. For aircraft, that's not a problem. For our missile, we need good response to respond immediately to any dynamic target, and reduced stiffness because of that. And next, I would like to tell you that additive manufacturing. Additive manufacturing we can integrate with our hydraulic fluid power. This is a natural process. I was telling that human also, you can say that we are hydraulic people because of our blood, and this is also here in the natural process. That means when we are born, we are 3 kg or 4 kg, whatever, and we are adding it. That is called natural process. So what is the advantage of this is you can make any shape like our biological thing, any shape. Only you have to put in the drawing, and you can feed it to that additive manufacturing thing. Then you will get whatever shape you want. Otherwise, we are playing with say circle and square and triangle like that. It is not like that. You can make any shape. That's why it is more going to be used in all biomedical engineering. And you can see here. Generally we will make it in the spool or bushing. We will make it as a round hole. This is replaced with 3D printing. We can make it any shape. That means they are a rectangle hole. What is the advantage? Because of area is more, your delta P will be reduced. That is why they are using this thing for all additive manufacturing. Also hydraulic fluid power they are coming, and you can see the manifold with a 5 kg. It has come down to 1.3 kg, 74% reduction. So wherever you want to use it, first of all, I would like any space application. Each kg is having around more than 2,000, 3,000 requests upon the your range. Each kg will require 500 kg of fuel. That's a there we can use it. When it is going to last stage, we have to reduce the size and weight like anything. So that's why we can see here reduction of fluid manifold, how it is reduced. And again, you see, this is first metal 3D printed primary flight control system. They are using AS350. Only limitation here is how to qualify and how to see that it is a fail proof. Now they are doing a lot of research on that, and they are making a lot of coupon and all. They are testing it in a very systematic way, and they are trying to collect a lot of data generation also they are doing. Then it will be used in a big way in the fluid power, because then you can reduce the weight and size like anything. So this is what another application, because it's a natural process. That's what I want to emphasize here. It's a natural process like a human, because we are born also it's natural. We are 3 kg. We are additive manufactured people. We are 3D means we are additive manufactured being. That's why this is a natural thing. Next is fluid power in Industry 4, because Industry 4 more towards communication and computer applications. You can see as per the manual or mechanical feedback valve 9060 switch electronic control and analog electronic control. Then it is coming to digital electronic control. Then finally it's coming in that multi field bus including diagnosis. Actually now in the the COVID period, what is happening is we have to see that now no one is coming to our place to any maintenance and all. We are thinking that this should be happen, because we are all now previously we are all wonderful people. Now we are wonderful people. We cannot move. We have to go inner. So this is what happening. So this is more applicable in industry 4. Whatever features they are telling that is applicable now. Maybe they thought that it will come one day then COVID like things. Next, IoT in fluid power. It is a integrated communication interface. We can see in that because of the time limit and telling that features and the integrated sensor and the future. Whatever we are having that fluid power, it will be more sensor oriented thing. And any small things also we can easily come to know, and we can do that diagnostics online and see that it is not breakdown is not there for more time. And integrated sensor and powerful digital control and intelligent fault diagnosis method. So that is the way I am telling that we have to have first of all the technology and science in the country. That's why Saraswati is sitting on the frog. Once we are having the technology, then only we will be stable. That's why once you have Saraswati with you, and Lakshmi always come back to you, because Lakshmi is standing on the lotus. The lotus means very weak and unstable. Money will not be there always. And once you have this through, then you will be a very strong country. That's why the new leadership of our country is telling that we have to make it everything in a country. That's why I told make in India. All should be done in the country. They are having their own vision and they are implementing also. That's why Saraswati is more important, and Brahma is a creator, designer. Saraswati should come with Brahma, Lakshmi and Vishnu maintenance, and Shakti and Shiva is annihilation. That's why we as a country, and we have to think always as a country we have to be very strong. Then only others will respect. But our country problem is not from outside. It is our own media and our own people. Nothing to do with outside the country. Once we are strong, then all will align with us, because 2000 years or thousands of years back, we are only strong in all the technologies. Our rishis are called saint. I will always call them as a scientist. Actually, those people are really done, and we can see that all the things thousands of years back it was there, but because of our modern, the British education, still we are following after 75 years. We lost our innovation. I can tell you, we lost our innovation. Those who are going out of the country, they are all shining. And again, I would like to tell you that almost all chief executive of MNC in the MNC in the world over, all are Indians, because we are by birth. This country is innovative place, innovation. Always I will tell you that our colleagues that scarcity leads to innovation, necessity leads to invention. That's it. We are in the scarcity. We have to see that how we can wherever we are going, we have to have that innovation. We are giving everything free, the innovation will not come. Our brain should work means we have to see that scarcity is there. And now the COVID period also, a lot of things done in our country. If you are seeing that vaccination or And we are DRDO is contributed for all ventilator, all the walls are designed in RCA, and it is produced in record time by BEL. All these things record time. If you are filling that 30,000 numbers within 3,000 ventilator within 3 to 4 months. Just imagine if the time comes, we will do the best. And we can see the electrical. I am telling that now we are talking about the fluidics. Then microfluidics also. Now it is additive manufacturing started on. This is called electrochemical additive manufacturing (ECAM). In this there is what is the features is low temperature, no power, no heat, no laser, no melting. And tiny and miniature devices we can make like the microfluidics things. So this is what new things are coming. Microfluidics most of the place they are used in biomedical applications. So we have to see that this should be integrated, and we have to see that the product is coming out. Somebody should because of whatever reason in the Western country they are investing a lot of things in that area, and even it is application is there in the sensor and integrated chips, microfluidic devices and MEMS. They are telling the features up to 2 micron we can get it. Otherwise, the general additive manufacturing, each layer thickness is around 20 micron. That is the reason we will not get less than 30-35 micron accuracy. Not only that, we may to go for the post processing to get final things. Next, and this is all evolving in any system, and we will tell in Gita in 3rd chapter body. Above body is senses, national sensor. Next is mind, and above mind is called intelligence. Oh, those who are intelligent people, they will go to spirituality. They will go to soul. And this is connected to our own body, because our rishis knows this thousands of years back. Now only each one is coming in the Western country, and they are appreciating better than any Indian, because our mind is full of money matter maybe. So Annamaya, that means a cell. Annamaya, that means whatever food you are taking, that is called Annamaya. Then Pranamaya is your energy body. Manomaya is your mind body. Vijnana means your intelligent body. Above that is called Anandamaya, nothing but we will tell that ecstasy. And in this, if you are seeing that, we will tell that little bit of karma theory. If we are going beyond that Manomaya, Vijnana and Ananda, whatever karma you do, that will not affect you if you are reaching that level. And in the engineering science, will tell that symbol, data and information, knowledge, and knowledge is applied is called wisdom. And our countries know that our education system is wisdom. And ancient education, they will tell you self-realization, that is nothing but wisdom. Then modern education is telling that self is realization. That's why we are unable to do many things. And we can see that our engineering thing. And the Western country, what they told? First they told you are physical. Then they told physical chemistry. Then they told chemistry. Then they told biochemistry. Then they told biology. Then they told not only biology or psychology. Now they are telling spirituality. This is what our rishis told thousands. They are called real scientists, not the scientists of signature. Scientists. And Western country they started to, we were there, that is called IQ, EQ, SQ. Unless you have EQ, you cannot interact. IQ is only, I can say that intelligence quotient they will tell, and EQ is emotional quotient. If you are synchronizing these two, you will become a SQ. The SQ will come when you are going to temple in front of Ganapati. We are doing that Thopu Karnam in Tamil, they will tell. That is for in synchronizing IQ and EQ. So you can see that in the Google search you can see a lot of things. Already the Western country they have done a lot of research, not in our country, because our rishis already told. Now what is happening? Any system, not only the fluid power, first is called sensory. I can tell you that what is sensor. Then it is going actuator and sensor. That's called actuator. Mechatronic system that already Professor Singha told to our advisor that mechatronic, that's a control. Control is external, nothing but sensor, actuator, and controller. And adaptive is embedded along with the thing. And intelligent. Now they are thinking about intelligent. That is called sensor, actuator, controller, and processor. All should be there. The system is intelligent, and it will give a self-diagnosis. Everything it will have. So that is why we are telling that we have to go to intelligent system, not beyond. We can go beyond that.
Dr. Suresh Kanan here. Just request you to conclude in 2 minutes, doctor.
No, not 2 minutes, 60 seconds, not minute also.
Thank you, doctor. Appreciate it.
Yeah. So here I can tell you that we are come from that super. Who can do nowadays? We are an AI. Who can do? Only those who are gone beyond the intelligent person. That's why Above intelligent person only can do AI better. This is told by some time back by the father of computer. And we are supernatural. Naturally, we are intelligent. You have to come to the natural level. Then only you can innovate and invent. Then you can go to mentality. That's your mentality is because environmental. And finally, superficiality is societal. So we have to think where we are reaching the highest. And we can make intelligent system. We cannot make a spiritual system in the mechanical side. Thank you very much for your patience here.
Thanks, Dr. Karunanidhi. Thank you very much. Quite an insight in the short time. Well, no time is enough for your speech. Well, every time it's motivating. You're doing so many research for us in the space program, and now in the pandemic time, DRDO is doing so many things. So thank you very much, and
thank you, sir.
Thanks for being on this session with us, sir. Thank you very much. Yes, we go on now to give our next presentation. This is for our late Mr. M.S. Yoga Narasimha. Yoga, as we all call. Let me give his profile and then what we are trying to organize during this. Yes, that's Yoga, always handsome even at this age. I wish I can be like him. So Yoga, he is a mechanical engineer from BMS College of Engineering. He started his career at CMTI and he devoted more for the development of machine tools at the time. Then from there on, he went to Europe for about a year for studying manufacturing engineering. While he was at CMTI, he was excited on this new developing field of hydraulics, because at that time, hydraulics was quite primitive out in India. And he had developed a special liking for it. He worked on hydraulic design systems, components, and they created a contamination lab there. So a lot of things was done. And under the leadership of Mr. Venkatramaya, a small group of people decided to form the FPSI. Okay, so he's one of the founder member of FPSI. This group also brought into its fold some interested engineers from NAL. Then around 1980-81, the position of chief was available in Wipro R&D, and that's where our Mr. Sitapati Rao, as we call him, MSR, checked with Yoga whether he would be interested to move to an industrial environment, more from the research. He was quite excited and immediately he went on to join Wipro. At that time, when he joined, MSR told Yoga that he would not be expected to be a brilliant R&D engineer. MSR was expected to manage and build the R&D function such that we have a team of outstanding R&D engineers, which will be the finest in India. Yoga accomplished this admirably, and the results was Wipro moving from an underdog to undisputed leadership in cylinders in India and also now globally. Yoga served Wipro till his retirement. And as I told you, he was a founder member and he has been all through active until we lost him this April. To commemorate his achievements in this, one is a prize award that we are going to encourage from the FPSI. This will be an institute, an award to honor and perpetuate the memory of our Yoga. The award will be named the MS Yoga Narasimha Prize for Innovation in Design. The MSY prize, that is, it will be a gold medal and a certificate, will be awarded to the best innovation in design, which can be components and systems. Engineering students and engineers with less than 5 years of experience will be eligible to compete for this MSY prize. A corpus of anywhere from 1 lakh to 10 lakh is proposed to be collected from the associated industry and others. The yearly interest will be provided for gold medal to be given to the winners. If any company matches the corpus collected by the FPSI, the award will be named as the company and MS Yoga Narasimha Prize for Innovation in Design. Nominations are invited for the same. Okay, now in recognition of the achievement and contribution to the national technological excellence of Mr. MS Yoga Narasimha, the Fluid Power Society of India is pleased to posthumously confer the Pascal Award 2021 on Mr. MS Yoga Narasimha. We have invited his son today to join us on this occasion, Vikram Simha, to accept the award on his behalf. Vikram, thank you very much for joining, and it's an honor to give this award to Mr. Yoga. And we would like you to say a few words on this occasion to the society who is watching you live. Thank you very much.
Thank you so much.
I'm so sorry to interrupt. Mr. Vikram, we will be playing a video with memories of MSY sir, and after that we will have the award ceremony. Thank you.
Thanks, Joseph, for intervening. Thanks for the video, Joseph. Again, just to announce award in recognition of the achievements and the contribution to the national technological excellence of Mr. M.S. Yoga Narasimha. The Flute Power Society of India is pleased to posthumously confer the Pascal Award 2021 on Mr. Yoga Narasimha. Vikram, we would like you to say a few words, if you can.
Yes, good evening, everybody. A few familiar faces, a few new faces that I personally have not met or come across in the past years. Having my father dedicate his entire career, starting from his engineering days up to probably end of March 2021, his dedication, his love towards fluid power never ever faded away. To have him be part of such a wonderful organization as FPSI, to have been part of Wipro in the past and CMTI as well. I think every day, night, every breath he took was about fluid power and how much he could contribute and what he could do to improve and how much knowledge he could share with people. I very well remember Mr. Rao, a long time since I saw you, but he was very fond of Mr. Rao, and a lot of you all he used to mention every single day. I don't think there is a single FPSI meet that he missed, or probably the recent, due to pandemic, most things were online. Hence, I think physical interactions were at minimal. But then his passion, his career and dedication towards FPSI was unmatched, like many of you have said in the past. A lot of beautiful pictures I saw in the video. Most of them which I haven't seen, I would definitely request Mr. Joseph to share some with us as well. But otherwise, this award, I'm sure, would have meant the world to him if he were to be around us now. Nonetheless, I'm sure he's looking down upon us, and it's a very proud moment for us as his children, both myself and my sister, who could not unfortunately be on this call. She's in the US right now, but she did want me to convey how thankful we are to FPSI and to every individual who's part of FPSI to have recognized him and to have given him this Pascal Award. I thank each and every one of you to have involved him in every aspect of your professional and personal life in many ways. And I thank you so much for this, and thank you so much. Thank you.
Thanks, Vikram. Thanks for joining us today. So we move on now on FEPD after giving awards to two great people. The next is the next very interesting one is the panel discussion. This is going to be moderated by my friend Seshnath, who is the CEO and MD of Valve Oil. So I hand over to Seshnath.
Thank you very much, Suresh. I'm sorry to keep the panelists waiting, but we were in the midst of some very interesting talk by Dr. Karunanidhi, and we didn't want to interrupt that. It was wonderful, Doctor. Thank you so much. In the panelists today, among the panelists, we'll have Mr. Sitapati Rao, who is the MD of HiCom Engineering, and I'll briefly inform you about him later. We have Mr. Shandar Alam, who is MD in Parker Hannifin. We have Rashmikant Joshi, who's MD of Festo India. We have Upinder Razdan, his MD of Danfoss in Pune. And then we have Deepak Maiti, who's the President of India Operations for Cymerix. I don't see Deepak. I think you'll have to buzz him, Joseph or Srinivas. Please check. Anyway, so in the meanwhile, I'll just give a brief introduction to our panelists for the benefit of everybody. Mr. Sitapati Rao brings with him an extraordinary track record of entrepreneurship and business leadership. Rao's has been a unique career in strategic thinking to conceptualize a high-tech business coupled with execution and organization building to create an extremely competitive enterprise. For over 30 years, Rao was the head of the precision engineering, that's the fluid power division of Wipro Corporation. He was responsible for the historic decisions of Wipro when it was still a small company to get into high-tech businesses and to venture out of its traditional geographic base of Bombay and move to Bangalore, which also paid off dividends for them in the IT business. Rao conceptualized the diversification of Wipro into the fluid power business. He virtually built the business brick by brick through deep involvement in all facets like market analysis, customer relationships, product development, manufacturing technology, people development, and good governance. He has extensive international business exposure in terms of interactions of technology transfers, equipment selection, exports, and so on. He has been the president of Fluid Power Society of India in the past and has been associated with it ever since the beginning. He was also the co-founder and chairman of the Fluid Power Division of their CII Fluid Power Division. Fluid Power Society is now working very closely with CII, not just because it doesn't have a Fluid Power Division, but with the main body of CII. So we hope to be bringing more good news to our members. Rao retired as the president and managing director of Fluid Power Limited, and he was also the member of the Corporate Executive Council. After his retirement in 2009, he took over HiCom Engineering India Private Limited, a precision engineering company making white label contract manufacturing on a tier 1 basis for OEMs. Rao is a chairman and managing director. He holds a master's degree in business administration from IIM Ahmedabad and a bachelor's degree in mechanical engineering from the University of Mysore. In recognition of his contribution to industrial development, the industries in Hindupur area honored him by naming a street after him. Wow, I didn't know that, Mr. Rao. Fantastic. Okay. Our next panelist will be Shandar Alam. Shandar Alam, he's the country managing director for Parker Hannifin India. He's got over 25 years experience, out of which more than 15 years is in the fluid power field. Earlier to this, he was working with Eaton as their country head. He has worked in various other leadership positions, and in Parker, he heads the manufacturing and marketing of hydraulics and pneumatics. I'm sure we will see a lot of dynamism coming out of Parker in the coming months. It's not good news for the competitors of Parker, but good news for the employees of Parker and for the customers. Our third panelist is Mr. Rashmikant Joshi, who is the managing director of Festo India Private Limited, a wholly owned subsidiary of Festo AG, Germany. Festo is a world leader in the field of industrial automation for factory and process automation. The company also offers a comprehensive range of learning systems for industrial training and education, from seminars, training and consulting in 39 languages to e-learning and complete turnkey learning centers. After completing his Bachelor of Engineering in Mechanical Engineering from Gujarat University, Rashmikant Joshi went on to Germany to pursue his master's degree in Industrial Engineering. He has also received Master of Business Administration degree from the University of Applied Sciences, Esslingen, Germany. He has been part of Festo India's journey to becoming the market leader in pneumatics and automation right from the beginning. And since 2002, He is a managing director leading India's Festo's business in South Asian countries. Our fourth panelist is Upinder Razdan. Upinder Razdan is a stalwart in the fluid power industry. He's been associated with Danfoss in various capacities, earlier working with Dantil Hydraulics and distributing Danfoss products. And after Danfoss set up their own operations, he joined them as their virtually first employee. He's now the managing director of Danfoss Power Solutions in India, intimately also working with all the other Danfoss divisions in India. He's been closely involved in the acquisition of Eaton by Danfoss recently and has his hands full in handling the transition. Our last panelist is Dr. Deepak Maiti, who started his career as a R&D engineer at GM or General Motors after a short stint as an assistant professor in BITS Pilani. Of his 15 years experience in the automotive industry as part of General Motors and Mercedes-Benz, he was involved in digital product development, including design, simulation, optimization, testing, and validation of powertrain systems. He is currently heading the India operations of Cymerix Incorporated, which is a Seattle, USA headquartered company, and which is into the business of engineering, simulation, catering to fluid power, automotive, aerospace, and many other industries. Its flagship product is Pump Links and extensively used for designing of pumps, motors, compressors, etc. Thank you for your patient listening. We will start the panel discussion now. The way it's going to work is I'll be more a facilitator. We will have a 5-minute opening speech or talk, sharing of views by each panelist whom I'll be calling to the screen. And this will last, the 5 panelists it'll be 25 minutes. And we will do the round robin again for 5 minutes so that the panelists can add on more of their thoughts and ideas and opinions. And this could benefit everybody at large. I invite Mr. Sitapati Rao to start the panel discussion. And the topic being, how can we make India one of the top 5 manufacturing hubs in the world for fluid power products? On to you, Mr. Rao. Rao, I think you're muted, Mr. Rao. I request all the other members to kindly mute themselves. And as and when the panel, and I call the panelists, you can unmute yourself and start speaking. On to you, Mr. Rao.
Good evening, gentlemen. In the Fluid Power Society of India, we have been talking about various topics of a now and here kind of activities. In the recent past, we've been talking about what can be the long-term view to take the fluid power industry in India to much higher levels. So that's how the thought came up, to make India one of the top 5 manufacturing hubs in the world for fluid power products. So this is over a period of time, and we need to set a clear direction for that and make sure that there's a synergy and there's a congruence of opinion, congruence of ideas among the industry and FPSI and the national plan. So is there one? And where are we? How are we moving? Is the issue. In terms of a broad indicators, what we have is that India today seems to stand at 7th position in the world in the manufacture of fluid power products. Whether it is manufacture, I'm not very clear. What I got is the total demand in the country. We are at about 1.5, 1.6 billion US dollars. Above us is the UK, which is about 1.8, not too far off. Japan is the higher, 4.5. The other European countries, apart from Germany, is about 4.6. Germany is 8.5. China is 15.6. And the USA, which is the largest in the world for fluid power products, is $18.27 billion. Now, for us to become one of the top 5 doesn't seem to be a big job. We just have to go 3 times as much as we are now. So, which is the kind of situation we are in. So that is the kind of objective we have. And we want to pick up the best of ideas from all of you to contribute so that we in FPSI also change our course or set a proper course to help industry achieve that. The objective we think is achievable as India has a large and growing home market. You know, if you want to be globally competitive, global size company, you always need to have a home market. That's a prerequisite for any industry. Unfortunately for us, India is a home market, strong home market. And India is also, fortunately for us in industry, an underserved home market. So there's a lot more that can happen. We're not a mature economy where everything has been done, all the roads have been laid and everything has been done. Far from that. So we are an underserved economy that gives opportunities for us. And we have a large pool of qualified manpower. A fluid power industry to grow and blossom requires very strong manpower, and we have that in good measure. We have a competitive advantage in costs. That's an important thing. Again and again, it has been proved that engineering industry in India is cost competitive. Our exports are actually rising. We're doing well. Multinational companies have come to India more for cost competitiveness than for the market size. For many years, our market size was small, only now it's growing. The present situation or present time seems to be the opportune time for us to aim high and grow big very rapidly. So this is the point I'm trying to make, because our attitudes, our goals, and our ambition will have to change. It is not just selling a little bit more. It is not growing by 5% per year or 10% per year, which is more than what an American company can show. It is growing 50% per year compound or 60% per year compound. So at the top level, at the CEO level, we need to change our mindset saying that this is the kind of a thing I would like to gun for. And which company doesn't want to do that? Once we have a coherent case to do that, companies would love to do that. So we have a source of opportunity for the whole world. A rapid growth in this field will help the fluid power industry in India as well as individual companies. There's a total congruence here. The fluid power industry will grow, the fluid power industries will grow, fluid power society would have met its objective. It is an objective which it creates a lot of winners in India. Now, as I said, we are currently 7th in order and we need to go up to slightly. My feeling is that in about a year's time, if the economy picks up well, we'll surpass the 6th player, which is Britain, which is UK, and we'll be in the 6th position. And then it will be a tougher race. We need to grow 3 times. We can do that if we have size of manufacturing. Now, what do we need to do to do that? We need to go to about 5 billion size of the business, which means that scaling is what is required. We have the talent, we have the companies, we have most multinationals available in India, and we've got the Indian multinationals. Just think of Wipro and Dynamatic, 2 Indian multinationals who not only dominate the Indian market for their products, but they are all over the world. They do that. So we need to emulate that. All the multinationals in India will have to think much bigger and be able to do this. FPSI will, of course, continue to encourage all companies in India to grow big at every available opportunity. You will find that in any meeting we have, anything we do in FPSI in future, we'll be talking about where are we and where do we want to go. So we'll be trying to goad the Indian industry to grow fast. So this is where we are. We believe that there's never a time as good as now to achieve breakaway growth, not incremental growth, the breakaway growth. So this is the issue we have on hand. We think there are opportunities. We want to pick the best of brains in the country to help us create a path for this to happen. That's why we are all here, and I rest my case. Thank you.
Thank you, Mr. Rao. It was excellent opening remarks from your side. I'm sure it has set the tone for the panel for the discussion. I now call upon Shandar Alam to give his opinions.
Yeah. Hey, thanks, Seshnath. Good evening, everyone. Thanks to FPSI for having me here in this panel discussion along with the distinguished guests. And I would build upon what Mr. Sitapati Rao just said, and I won't repeat the number but looking at the data that we had in hand, the topic that we have, making India into the top 5 manufacturing hub. While the market, the demand, what India offers is about $1.5 billion, and if we really have to move into those top 5 ranks, we need to be somewhere in the range of $5 billion size, right? So the manufacturing output itself has to cater to those 5 billion plus market if we really want to be in that top 5. And it's no brainer that it cannot happen just by focusing on a domestic market. And if we really have to be in the top 5, while it's important that we need to look at a local market because there's still a lot of imports that happen, but we need to be global, right? So now the question on our hand is, how do we grow and really export more in addition to what we can cater to the domestic market, but can also go out in the global market? How can we capture some of the share in US, Europe, Germany? Can we replace China in some of the markets? So those would be the questions that would come in if we really have to compete in the global space. To my mind, what do we need if we really want to position India in those ranks? The manufacturing capability, right? We do have a good amount of capability here with global multinationals have their manufacturing footprint. We have a strong Indian organization who has a strong manufacturing footprint. But I think we really need to step up, right? A step up in terms of moving into a mindset of zero defect, evolving into industry 4.0, what type of automations, what type of process controls that we have. Because please remember, if we want to play in that market and want to play in that market big, the risk is very, very high, right? The cost of the warranty can erode the whole profitability in the business if we don't do things right. So there has to be a good investment and thoughts around that, with a lot of focus around sustainability as well. The second important piece that comes in is absolutely on technology, right? We need to migrate from the conventional hydraulics or pneumatics to a more products which are more safe, reliable, compact, light, more energy efficient, intelligent control. So those are the technology products that we really need to have if we really want to play in India, in the futuristic market and in globe to really make a space for ourselves. We have skills, but we need to constantly develop on the skills. We need to have skillful people, so people development. And of course, this FPSI, which is the industry body, has to very, very closely work with the government in terms of also laying out the foreign trade policies, developing the infrastructure, which is so key, making the logistics very, very efficient, right? So these are few of the actions that this industry body has to collaborate with the government of India to act as a tailwind and really make and improve ease of doing business, which can really attract the global multinationals to really put their money in country like India, and at the same time help our homegrown companies also to invest and scale up, right? What we need is a more of a tailwind from the government policies as well and some of the infrastructural support. So if I have to summarize in this, I would say what is key for us is make for world. Local for local would take us to certain rank, maybe up to 6th. But if we really want to be at the 5th and better than that, it has to be made for global as well. So that's what I would summarize my comment with.
Thank you so much, Shandar. It was very eye-opening thoughts, and I'm sure we are looking forward to more thoughts coming from from the other panelists. I invite Mr. Rashmikant Joshi to start his talks, please.
Thank you, Seshnath, and good evening, friends. Well, it's always tough to talk after Dr. Sridhar Rao has spoken. Practically, you should keep him last. He will add far more value to what all we will say. Excuse me if I may have to repeat more or less a few things what MSR said and what also Shandar said. But I think it is a must to reinforce how we can achieve what we are supposed to achieve. Mr. Sridhar Rao said quite nicely that we just have to grow 3 times larger, and that we are not far away from. And as we know, India is making progress, so we are growing faster. But as we go higher, the air starts becoming thinner, and it gets tougher. So whatever is good, we have to agree that is not good enough. We will have to strive much higher. So what I'm going to say might sound a little critical, but it is well meant. So let us talk, or let me say first of all that today we are talking in the large automation landscape, limiting only to hydraulics and pneumatics. And if you look at my view, it will further be influenced more from pneumatics angle than hydraulics. Although when we speak about manufacturing technology, there is clear overlap between hydraulics and pneumatics. So to bring India amongst top fluid power manufacturing countries, whether we call it in top 5 or top 3, there is a prerequisite like what MSR said, and that is to increase local demand. And in this short time given to me, I'll quickly touch upon this aspect first. How to increase local demand will remain another topic. Now, if we really look at which are the countries we are talking in the world, it's primarily Japan and China in Asia. In Americas, it is USA, and in Europe, it is Germany. Well, France, Italy, UK, these are okay, but they are not as large as Germany. Now, to become a significant manufacturer of fluid power products in the world, we need to have volumes, and volumes for local market or even for global market. And if you really compare or speak about the countries which I mentioned, how did they do? They have had first the large local market, and then they built upon it the export market. So if we really think of how can we create volumes, one is, okay, we spoke that increase local market demand. So to have volumes, we need to create demand. And this would really make it attractive, like what MSR said, that it will make attractive for local manufacturers, but also it will attract foreign investments. Another way would be contract manufacturing for exports, the way automotive industries, tier 1, tier 2 suppliers are doing. Contract manufacturing, but this would be very cost driven, and it may not be very sustainable standalone. It is okay with other ideas. And there is another way, like the examples were given of Wipro and Dynamatics, that local companies establish themselves globally and acquire global volumes, because finally we need volumes. But it's not very easy, and especially coming from low volume countries, it is not easy. Anyway, we need combination of all. But what are our current challenges based on this low local demand and very low export of fluid power products? That we have low manufacturing capabilities. Let us agree that though we are doing better and better year after year, we have low manufacturing capacities and capabilities. If there is a large volume demand, we will need longer lead times. Another thing is all our suppliers, they have need of investments in manufacturing and manufacturing technologies of raw material or components of required quality and specifications, but they cannot do it because the volume requirement is low for local market. We already spoke earlier, we have limited trained manpower. Even the knowledge and competency at end users is also limited. If you think of other countries which are already there, the end user has good knowledge of fluid power and thereby less demand from the fluid power industries. And that helps grow the market pie. All in all, we have also have higher import dependency. So if in the first round, if I quickly sum up, what we need is we need to increase local market demand, and that will increase technical and commercial competency, and that will help increase contribution to global demand. And this way, this in turn will increase local manufacturing of fluid power products, and we will increase higher in the ladder. This much from my side, Seshnath.
Thank you very much, Joshi. Very refreshingly different points brought out by you, both positive as well as giving a kind of a status report of where we are now and what's the kind of roadmap we need to adopt going forward. Excellent. I now call Upinder Razdan from Danfoss to share his thoughts with us.
Now I'm in effect, so I mean all three panelists, senior panelists have said everything what we were supposed to say. But I mean, great views from all three panelists, especially Sitapati Rao, Shandar and Mr. Joshi. As Shandar, you said that we definitely need a tailwind, and tailwind we have. I mean, we have enough elements which are giving us tailwind, like we have still cheaper cost labor. Even if you compare with China, it's a relative thing. We still have kind of an availability of skilled laborers. That's always there. But if we look at the homegrown, I mean, that's the first fundamental. Any multinational comes to India, like we all are from the same company, similar companies, and then they first look at the home market. I mean, okay, how much is the home consumption? And we have been, I mean, personally, we have been in the industry for so long. We have been struggling to grow this market because it's not something we can influence. It's not something we have an influence on the government regulations, whether it is on like you have in US and Europe. And same OEMs who work differently in Europe, but they work differently in India. And there are logical reasons, because first is the acceptance with the end user of the technology we are trying to give them. So that is a big challenge always, especially in hydraulics. I know pneumatic is still accepted, but hydraulic is a difficult game when it comes to the end user handling and what is the service kind of support. So that is restricting certain kind of an horizon for our OEMs to grow, because we are B2B kind of a business support to them. And the third point I feel is that the complete supply chain. I mean, no company can be comfortable manufacturing things in a country by not having the proximity of their supplier base. And that's why we struggle a lot today. I mean, even though, as Mr. Joshi said, that we have improved, but I don't think that's enough. And the approach and the attitude of those kind of supplier partners, it's very difficult for us to get them to invest. One is that invest in the capacity, that's fine, but they invest in the technology, invest in the quality. I mean, they always think that quality is an expense, but it's not an expense, it's an investment for the future, which can give you returns very quickly year on year. So that's a challenge we always face when we go to that kind of a complete link of the supply chain. And export, yes, I mean, that has to be balanced. Import and local home business and the export business, it has to be 80-20 or 75-25, not more than that. Otherwise, it doesn't make sense to make in a country. There is no market in the country. And this new thing, what is happening in last, 12, 13 months, I mean, at least in my company, I mean, not to be quoted, the mindset has changed. I mean, mindset has changed that they want that, like we say, I mean, local. Be vocal for local. I mean, it's happening that people are trying to shift. Initially, it was China because of the tariff issues. Now people are trying to look at a possibility of moving their supply chain back to their own proximity because they're trying to be safe. Because what happened in the last 12, 13 months, and that's creating kind of a scare. Whether it's right or wrong, I don't know. Whether it is a knee-jerk reaction, yes, for me, if they ask me, I say it's a knee-jerk reaction. But we have also given them enough trouble in these times where we have not been able to scale up in all respects, basically, whether it is making our commitments fulfilled on time or consistency in the quality which Chandar you mentioned. I mean, that is a challenge. I mean, we also feel that challenge. So how do we manage this complete horizon of the supply chain? That is the challenge, and that is the challenge we have been trying to do. I mean, FPSA is doing quite a lot, but I think unless and until we set these kind of concerns on the right track, it will be always a struggle. It will be always a struggle, but ambition is always there to bring it to scale up our spend of fluid power in India to multiple levels. We are trying it. I've been in 30 years. I've seen, I mean, very few new applications have been developed. I mean, if Caterpillar makes, I mean, how many loaders we make in India? I mean, this is minimal. I mean, if I talk about mobile hydraulics, our industrial is still growing, but mobile is still limited to certain applications. And there's no dearth of good suppliers, I'm telling you, but there's problem is that how do we create that confidence in them that, economy of scale in their business also has to be properly balanced so that they can take a chance to invest in the R&D in any kind of innovation. So that's the challenge. It's an open-ended challenge for us also to create a kind of a recipe that this today we are 1.8, or how do we go to 5 billion? I mean, we can have a step-up approach and then see that how we can do as industry and how we can connect with our customers or OEMs or some sort, and then create that kind of a mindset that, okay, we will come here, we will come bring more products to India, tell us what to do. Sign some kind of an agreement. I mean, Sheshnath and me, we have been in one of the meetings last year. That was the last supplier meeting we had at one of the OEMs, and we asked them. Shandar, you were also there. We will take 2 steps, but you take 1 step, basically, because there's no contract commitment. I mean, if you invest here, I mean, there's no commitment from the customers that, okay, yes, they'll stick to us. So, I mean, not that. There can be different reasons for that. I mean, nobody wants to bind themselves with a contract as we have in outside India. So these kind of challenging approaches of when our customers and our supply chain is there are two ends, basically, 2 key ends for us, and we need to correct them. We need to change that mindset. How do we do that? That's why we are here discussing it. It's just a start of the discussion, but we can always meet later on and try to brainstorm further on this. But then we have to meet the industry. And I mean, if we can join together, I mean, leaving aside our competition hat or all those kind of stuff, we can all go together, meet big OEM and tell us, okay, tell us what to do. What do you want from us? And then we can come forward and we can talk over parent companies or our own managements, and we can take a step. We don't promise them we can do it, but at least we can try. So maybe that's my summary of this, because it's a difficult subject to conclude and okay, this is what we should do. But there are many open-ended kind of elements we need to connect them and try to channelize them into the right direction. So that's me.
It's a eye-opening, different side of the coin, is what you are trying to expose us to, which is very valid, badly required. Opens out new vistas for thinking, especially your talk about would the end users welcome more supply from our side? Would they be willing to scale up their production? It's again valid point, because we as suppliers are dependent on OEMs to buy our products and use it. Thank you so much for that. I invite Dr. Deepak Maiti to speak about his thoughts, please.
Good evening. Am I audible?
Yes. Please go ahead.
First of all, it's nice to be here with eminent panelists and industry veterans from India, and also good to hear their views, particularly because I'm new to the fluid power industries, because the last 15 years I've spent mostly into automotive industries, as Mr. Sheshnath gave an introduction, primarily into General Motors and Mercedes-Benz R&D. So some of the points, definitely I have taken it down, and it's a learning for me. One thing I could understand that we have to create the demands. That's one of the very important things, as you can understand, to take India as fifth largest. On the other hand, I see that it's not a difficult target actually, because the way we are going and the Indian economy is growing, probably at some point we'll reach there. But one point is very clear, that we have to go faster. We should not be happy with whatever we have been doing so far. Probably we have done very good for some of the sectors, like demand for the fluid power industries, as I understand, primarily came from the construction and mining. Then we see it's not only construction and mining, but also with government's focus or initiative to reduce the defense budget for procurement. Probably aerospace and defense will open up some scope for the fluid power industry. That's my anticipation. And on the other hand, if we look at the global growth, which is at a 6%, which is well and good, because I have been reading the International Fluid Power Association report and also National Fluid Power Association report from US. They are very optimistic because they have given the chart that it is going down and going up, because a lot of new applications are coming into the field. And probably I take a point from Mr. Joshi, if I'm right. He is talking about the application of pneumatics, or the market of the pneumatics is going to grow compared to mobile hydraulics or industrial hydraulics. I think I was reading the same. And in fact, from my interaction, mostly from the product engineering point of view, because Simerix is primarily into product engineering and technology for developing quality products. We have been interacting with some of the Indian companies, homegrown companies. Definitely, global R&D is already they have been doing a lot of product engineering in their headquarters. And in fact, many of these biggies like Parker Hannifin, Mr. Alam, or Danfoss, they have been using global R&D centers to develop new products, like say electrohydraulics and other areas. But my experience with, I want to share with you some of the Indian companies that I see, particularly in the pneumatic side. There are small players on the pneumatics, but still they are not open to the technology and the quality product. And what I hear from Mr. Global brands like Parker Hannifin, Mr. Alam, and also from Danfoss, that quality is very, very important, and technology is very important, because it is, if you are to scale it up, it is not only the Indian market or homegrown market, you have to go global. So to go global, one thing is very clear as I take away, the cost of warranty, as Mr. Alam was saying, is much more risky than going global. So we have to, what I'm saying is that we have to test all the things in homegrown market before going into global. And all these things we have to do it fast. And we have to accelerate. So for that, 2 points I would like to highlight. One thing is definitely manufacturing excellence, whatever disruption is happening across the globe in terms of Industry 4.0, industrial automation, additive manufacturing, digital twin, IIoT, that is happening across all the industries. So I'm sure that all the industry veterans from Parker Hannifin or Festo or Danfoss, they have been driving those things. There is no doubt about it. But I would like to highlight more on the product engineering, because my experience on the product engineering from the Indian perspective, particularly as I said, I come from the automotive background, and if I take automotive is a success story in India for the last 10-15 years, if I name it. Still, Maruti Suzuki is the #1 brand. And then even if it comes Hyundai, they have invested a lot of money and skill development. So one thing always I get to hear from our global counterparts, that the supplier ecosystem is very strong for the success of the automotive industries. I think we need to do the same thing. Even fluid power industries more fall into the equipment suppliers. But I think we have a positive sense that we are not facing the disruption like automotive technology. So for instance, if I talk to the automotive suppliers, biggest suppliers, they're shifting their business from automotive to something else, maybe in the aerospace and defense. And they're the biggest supplier in India who are #1 in the forging and material science and all those things. They're investing more money into the aerospace and defense. Similarly, some of the companies like supplier companies on the bearing side, I was listening to their CEO that he's targeting twofold increase by 2025 from 2,000 crores to 4,000 crores. And he's making a strategy that less investment on the automotive, rather more investment into railways, construction, and other industries. So what I'm trying to say is that definitely the demand is the major thing which will drive everything. And once we create the demand, then all other things will fall into place. And it's more like if the customer is there, if the crisis is there, just like pandemic. So all the innovations, everything comes into the place. But one thing we have to be very agile in terms of catering to different demands. And for that, what I understand is that customization of the product is the key. So definitely, there's no learning for the global R&D, global companies like Danfoss or Parker Hannifin or Hesto, because they have the global expertise. So any point of time, they can bring it here in India and cater to different markets, like say growing demand, say for instance, aerospace defense. But on the other hand, homegrown companies, they need to be ready also, because at some point they will also supply to the ecosystem of the global companies. So as a whole, I want to emphasize, apart from manufacturing excellence, we need to focus on the product engineering as well to create a leap jump actually in terms of increasing the product quality, reliability, because even in fluid power systems, and I would say that there is not disruptions like automotive technology, even electrohydraulics, electropneumatics, all those things are happening, but still we are in a safer place in terms of this disruption, I would say. So rather, we can focus more on the traditional product development. See, for instance, say I was talking to one of the customers from the aerospace industries and defense R&D. There's a very high pressure pump like a piston pump. So there is a supplier in India to provide the swash plate piston pump, which works at the pressure of 700 bar for the landing gears. And in fact, government R&D is spending actually 6 years, 7 years actually to develop that kind of technology. But I know that Parker Hannifin is there because we are working closely with Parker Hannifin actually. So they have the swash plate piston pump. So question is that how do you bring that kind of technology and localize here in India to cater to the demands for the Indian industry? I think with that, as I said, I tried to add points, but it's very difficult after speaking at the last, after listening to all the eminent speakers. I try to add my points as far as possible from my knowledge of the product engineering. But definitely, it's quite interesting discussion, and thanks to FPSI for creating such platform. And I look forward to.
Thank you, Dr. Maiti. It was a very different point of view you were talking about in terms of improving the product reliability, sustainability, technology, and so on. Of course, we will go now for a second round robin in case any of you want to add on any other points. But just to make things interesting, and since also the cricket match is going on now between India and New Zealand for the World Test Championship, I thought I'll put in a small googly. Okay. Now the second round, I would also like you to explore whether the topic is, is it a bridge too far for us? I'm inverting the topic and saying, are we, India, in a position, and is it too aspirational for us to aspire to be among the top 5, say in the next 5 years? I'm just giving a time frame. It's just a googly, okay? I don't want you to develop only on this. Please add your other thoughts also. But in case you want to add some masala, okay, here's some masala for you. Okay, go ahead, Mr. Rao.
Yes. Taking your question first, Sesh, in my college days and my first job, I was a designer in a HEC Ranchi, designing some equipment for steel mills. One of the things was the steel plant engineering. We were very small. America was the leading manufacturer of steel in the world. Everybody else was very small. Today, America is very small. It is China which leads, and India is pretty large, surprisingly large in steel making. These things can change and do change. Second, just as an anecdote, supposing, most of us are bosses, or we can be our own boss also. Supposing your boss said, my friend, I want 100% growth in 2 years, without sacrificing my ROE, give me 3 different ideas, or I'll find somebody else for the job. I'm sure you'll give 4 different ideas. You'll do that because the creativity is there. You know, I tell you, it is not, it's a very old story. When we started Wipro Fluid Power, we were very small. Our first objective was to meet the size of our nearest competitor who was in Hyderabad. We met that in a few years. Then we said, what next? Then we said we must be meeting the output and exceed of the #1 in India at that time. We did that. That company was in Calcutta. Then we said, what next? Then we said we should be at least twice as big as our nearest competitor. We did that. Then we said, what next? Then we said the quality, which everybody is talking about, we should focus on that. We did a lot of work. We said we should be proud to have our product exhibited in Hanover Messe, along with all the international products, and not feel embarrassed by our product. That was an objective. We took our product to Hanover, we took up to Chicago, we took them to Tokyo. We exhibited our products. So we were able to do that. So I think if there is a lot of effort, many of these things are possible. Also, if you may kindly permit, I would disagree with Deepak Maiti, who says that we should get the technology from abroad and then do the modifications in India, use in India. It is not necessary. Well, I worked on a product which is not as high-tech as what you people do. I worked on hydraulic cylinders. We went around the whole world for getting a collaboration. My boss of 30 years, Mr. Azim Premji, you must be knowing the name. And we went around the whole world and selected many prospective collaborators, including Parker in those days. And when it came back, we said, what do we do? Our answer was that we do it ourselves, which is more difficult, but that's the best way to go. Because if you've got a foreign collaboration, if you want to change a comma into full stop, you call up New York or Boston or somewhere and say, may I do this? So we developed R&D as a technology. In fact, it was mentioned when we were talking about MS Yoga Narasimha earlier, that we wanted to create a technology core. We did that. So my feeling is that we are capable of doing a lot more than what we think credit for. We also heard Dr. Karunanidhi talking to us about what has been done in India. When the Western countries closed their doors to us in technology, we did many things. Maybe whatever we did was not as smart looking or was not as beautiful, but it did a job admirably. So my suggestion is that let us not, there are constraints. I mean, there are no constraints. In India, life is a tough job. There are constraints. But apart from constraints, can we break through and do something bigger? Can we say that we want to be there and what needs to be done? And here is where I think FPSI may play a catalytic role. FPSI is a small organization. It can play only catalytic role. Supposing manufacturers like us, heads of companies, periodically get together, let's say every quarter, in Pune, Bombay, Calcutta, Delhi, Bangalore, anywhere. And then each time have a different agenda. Call, let us say, once all foundry manufacturers of India, saying that, look, guys, these are the problems we are facing from you for us. What can you do for us? Collectively, this is our strength. This is the industry what we want. We want the quality, we want the output, we want the scalability. Can you think big or you cannot think big? So I think this thinking big has to become infectious. How did China become so large? They were very small. Many years ago, in my college days, Chinese economy and our economy was about the same size. Chennai city and Singapore city were about the same size and same quality. How did they do something different? How did China go to that level? How did China gain all the power and the arrogance that they now have? They have done a great job. So I think it's possible. Government will have to do that, be ambitious. Industry also has to be ambitious. So we have some things going for us. We have people, we have technology, we have ability to learn. and we have a reasonably good home market. So can we exploit them? And as industry leaders, can we grow big? Maybe we should consider.
Thank you, Mr. Rao. Thank you so much. You spoke this time about global benchmarking, about giving exposure to products globally and competing with them globally. I hand over the floor to Shandar. Some more thoughts from you.
Oh, yeah. I can build on what Mr. Ross said. Let me give you my perspective, right? And the question coming from you, Shesh, about can this 1.5 become 5 plus? Because that is what we are aspiring for, right, in 5 years' time. And I completely echo what Mr. Ross said. We all are leaders in our respective businesses. And I'm sure we have been building our own strategic plan for 5 years. I don't think any plan would be acceptable if it's not 2.5 or 3 times what we are doing today. So if all of us do 3 times, we are there, right? We are very much there. Now, I think the discussion that happened in the first round is on 2 things, right? Homegrown business market or being global. It has to be a combination of both. There's no brainer. We all exist today because of the homegrown market. No multinational just comes or most of them don't come and put their investment just for the global market. They want to see what the local market things are. But if you look at the data, the whole fluid power market is about $1.5 billion in India. And if we really have an aspiration to go to 5 billion plus, there are 2 options. Many panelists talked about either grow the existing market or find a new market. And I would say, if we really have an aspiration to go in 5 years, it has to be a good combination of both, right? And I can talk as a more from the multinational perspective. We don't see much of a challenge in terms of creating or developing a product which is futuristic, technology driven, intelligent, because multinationals has global R&D across in India as well as global. What we need is a strong manufacturing footprint. Now we have manufacturing footprint, but we need that mindset. Are we efficient enough? Are we reliable enough, right? When the stakeholders taking a decision sitting in Cleveland or Sweden or Germany, is India their first choice, right? We talked about our cost position is better than China, but am I the first choice when people are deciding? Because they are much beyond the cost, right? Our mindset is not as efficient as the global customer expect us to behave, right? So if we make that change on the behavior aspect of it, my problem is if someone is deciding a global business between India and other country, as a CEO of that multinational sitting in India, why I am not able to bring that business into India, right? And that's a big question because and that's where I talked about all the tailwinds and all the efficiency in our system that we need to create. And we need to earn our right and we need to earn in front of the global leadership when they're making a decision that we are not only to be seen as local for local, we are to be seen local for local as well as make for global. And that is what would take us to 5 billion plus in 5 years. And that's very much possible. I would absolutely be confident of hitting those numbers. I would put my case on rest. Thank you, Shesh.
Excellent, Shandar. The confidence that you have for India as a market, for Parker's role in India comes through excellently, easily, and very convincingly. It also gives us a lot of energy that senior people like you are so bullish about India, and it fills us with a lot of optimism. Thank you for that. I now pass the mic on to Joshi for your remarks.
So thank you, Seshnath. So before starting, I would like to say, Shandar, all what you said, tathastu. We all love that happen, in next 5 years. But Seshnath, starting touching upon the point you said, whether it is too aspirational to do it in 5 years. Well, I would not like to talk about timeline of 5 years. We all know potential, massive potential is built in India. There is no discussion about it. When will it come out? Okay, whether it is 5 years or 7 years, what number, 5 trillion economy, this economy, I think we can discuss. But the catching up of speed is an issue when it comes to India. We all know it. We are known to be walking at elephant speed. And for an organization to be over aspirational or aspirational is not difficult, because you can always steal from others and grow. Here we are talking about growing the market economy. We are talking about growing the pie. And there I would like to agree with what MSR said, that it has to be collective aspiration, not aspiration of individual organizations. So we need to do something to really increase that market pie and to grow. So this is one point I would like to say. I do see also opportunity that more and more the economy or businesses are moving to Asia. I think in all our organizations we speak about the growth in future is going to be, of course, all across the world, but more in Asia. And when it comes to Asia, which are the economies, which are the countries? Of course, China is already there, and next is India. It's not China but it is China and India. Again, the question is how fast, when, etc., etc. That's a different topic. But we know that it is short future in India. There is no discussion. Another thing also I would like to touch upon is, some of the opportunities that we have and how we can handle this. I already spoke about increasing local demand. So we all know that the user education is the core of local demand increase. And this is something where we really have to go a long way, user education. And trust me, it is just not going to happen. You cannot depend on exports. You cannot depend, or you cannot even expect people investing in India unless we enhance user education in field of fluid power. Maybe pneumatics in specific, but still. Another thing what we are definitely dependent on, because we can't, by no means we can grow over proportionately faster than the economy itself growing. So we need to increase contribution of manufacturing in GDP. Of course, one can write thesis on this topic. Another thing is also we need to increase our contribution in global world, so export of manufactured goods. I'm not talking about fluid power here. I'm talking about export of manufactured goods. I think this is something which has to, so Indian economy has to increase its contribution into global economy. And another topic I would also like to talk about is stricter implementation of norms. Example, food safety, hygiene, employee safety, energy conservation. I think these are all the things which will increase the pie. And already Dr. Maiti spoke about, for example, products becoming intelligent. And I see a huge opportunity here, because what is it, intelligent products? We're talking about electronics and software, something where India has already some platform and background and also people competency. So I think we do have opportunity. We are not over aspirational in this aspect, but also if you look at solutions are becoming hybrid. It's not hydraulics or pneumatics or electric. It's all end. So I think here again, if we have collective aspiration, we can really do something in this direction. And the last point which I would like to say is what also Dr. Maiti said, customizing of products, product engineering, but I would also say investment in R&D. We will not be successful unless there is an investment in people, user education, and investment in R&D. There has to be R&D closer to the markets. And of course, we also have to contribute into the global R&D for global requirement. This much from my side.
Excellent, Joshi. Some wonderful points came out in your second speech. It's a good sound bite and so meaningful in terms of collective aspiration. Wonderful, because it sets the tone that we are in cooperation among all of us. We have to compete in the marketplace, but we also need to cooperate with each other to ensure that the whole market grows. And the other one is R&D being, or technology being closer to the market, whether in terms of manufacturing or the end users. Wonderful points brought out. Thank you so much. Upinder, we are 5 minutes for you.
Yeah, I think 5 is too much now. I mean, because I echo most of the points what Shandar did mention. I mean, there's nothing wrong to be aspirational, and the house too you gave us, Joshi. I've seen it. I mean, in my personal experience, that we have been aspirational. I mean, sometimes too optimistic, but we have succeeded, and that's not come without any kind of a legwork. And as we say that, how can we grow? How can we grow our scale of business here? I mean, we have to steal it from somewhere. I mean, I'm talking about the internal company. If something is being manufactured in my organization in Germany or US, and can I make it better here? So that sales pitch has to be done from our side, and that takes hell of a time because everybody's possessive about his own area, his own country. So that's one area where we need to create that kind of a credibility on every aspect. I mean, whether we call them KPIs, it's quality, sustainability, consistency, and commitment. I mean, adhering to commitments. And on top of it, if we don't, or our sub-suppliers don't invest on, as you, Joshi, rightly said, on R&D. Of course, investing in the manpower is fine. That's what's going on. But spending on R&D is still a taboo. And they call it as a useless investment. Let's take the technology from outside and then we implement it here. But that's not going to be a long-term sustainability kind of criteria. And I have seen the success coming, being aspirational. I mean, India has not grown so much. I mean, in particular product lines or particular applications, the way we had anticipated maybe 20 years back or 30 years back. But certain applications have increased a lot. I mean, where the content of hydraulics has improved. I mean, we have seen that. All of us are in that business. But this is one area. The other area is still remaining very sluggish, very, very sluggish. Reasons, I mean, it's very difficult to analyze at this moment, unless and until we as an industry, we as an FPSA community, as we said in the beginning, and you also endorsed it, Mr. Rao and Joshi also endorsed it. Let's go as a representative of the Fluid Power Society and just meet those OEMs and tell them, please tell us what we need to do for you. And then we can, draw back our whole plan based on that, whether we can do it or whether we cannot do it. So I think that is the main element which can drive our aspirations to reality. Basically, nothing is impossible. I mean, I was making 10 years back or 15 years back certain components. I won't name around 5,000 a month. Today we are making 55,000 a month. Out of that, 85% goes for the home consumption. So it's a good development in the last 10, 12 years or 15 years. But it's only one pocket we are talking about. There are various pockets, whether it's pneumatic, whether it is hydraulics, electro-hydraulics, automotive, of course, is a different, I mean, we are not into automotive, but there are various areas which are still untapped. And again, end user, acceptance by the end user of the technology. We are talking now electro-hydraulics, we are talking electronics, we are talking software in the system. Is it something which we can drive through the organization to their end users and how it's to be used, how it is beneficial? Everything is boiling down to the cost. They need the best, but the cost is which is not driving them into a positive direction and buying those technologies. And that's always a challenge. That's always a challenge. But huge potential we have in India. Huge potential. I mean, I'm telling you home potential. We have huge home potential. It's still untapped. Still untapped. I mean, many elements have not been even touched today. And big companies are thinking, big OEMs are now thinking technologies. I mean, it's kind of an, I mean, it's not bad, not good to say it's a Me Too approach. I mean, if X is doing and then Y starts doing it, it should happen that home people should take a drive and start using the technology first, rather than getting driven by somebody else. So I still feel I fully endorse with Shandar and Mr. Rao and Mr. Joshi that there is a scope and there's nothing wrong to be aspirational unless and until we mess it up ourselves.
Thank you, Pinder. That was wonderful, especially a suggestion of FPSI as a body meeting various OEMs together, making a pitch and trying to understand the voice of the customer together and saying, look, we are here to represent the body of fluid power, that is hydraulics, pneumatics, automation, mechatronics, and what can we do for you? I think that's a brilliant approach, wonderful suggestion from you. And of course, not to say that all the other manufacturing metrics that you spoke about in terms of high quality manufacturing, reliability, and so on and so forth. Thank you for that, Upender. Dr. Maiti, last 5 minutes for you, because we are running out of time. So if you can confine it to 5 minutes, I'll be thankful.
Yeah, sure. I think I don't need more than 2 minutes after listening to the eminent experts. Probably I will start with the words that I completely resonate with Mr. Razdan. As I said, potential is immense, even in India, actually. I mean, definitely we should target for a global market. But I'm completely resonating with Mr. Razdan that we have immense potential in the Indian market. And also, I aspire, I mean, we all aspire that going to be not even fifth place, probably why not higher actually. But I think another point that I take it from Mr. Joshi, and I completely agree with that. We are talking in the first round of our discussion that we'll reach there at some point of time, like either fifth place or fourth place. But the question is that how fast? I think what are the enablers to reach there faster? I think that should be the discussion points. And one of the points that I like, and again, I resonate with the collaborative effort. As we heard from Mr. Alam, as we heard from Mr. Rastan, Mr. Rao, and also Mr. Joshi, that it needs a collaborative effort. And definitely the drivers are the government. Say, for instance, again, I'm talking about aerospace and defense. I mean, everybody was expecting that aerospace and defense will open up much earlier, because everybody knows that India spends a lot of money in procurement, defense procurement. And it's not known. It's there for the last 20 years. Now, slowly, aerospace defense is opening up to the private players. And the global brands like Eaton or Parker Hannifin or any big companies, they're ready to contribute to the development of the aerospace and defense industries. So definitely it depends on the government. And whenever government comes into the picture, I think the collaborative effort must, because again, I'm quoting Mr. Joshi that Indians are elephant, at least government is elephant. So we have to move the government, but Indians are not elephant. Actually. That's what, because we have seen during the pandemic, the kind of innovation, I would say. I've been reading a lot, and we have seen that many companies immediately converted from nitrogen plant to the oxygen plant. And nobody thought about oxygen generator. It's so simple, so simple. And as I was referring to some of the companies, they're just changing the molecular seeds. They change from nitrogen plant to the oxygen plant. And I take your words, Mr. Chestnut, that technology has to be close to the end users. And definitely, we as Indians have a huge potential, and we have proved ourselves in many fronts. Like as I said, automotive is one of the examples. Software, technology, electronics is the example. Electronics, I would not say, the software. So definitely, I'm more than 100% aspire to make India as fifth player. Not even the fifth player. We can go up the ladder. Why not? Thanks.
Thank you so much. Thank you so much, Dr. Maiti. Thanks to everybody. All five of you have brought some extremely valid points.
Just one last point. I mean, I don't know if it's valid or not. It's just for Mr. Rao because he's the most experienced. I mean, can we connect this FPSI very, very efficiently with CII? Because CII can help us. I mean, in moving the industries towards, I mean, in the right direction, whether it's a regulation, whether it's any kind of thing. So how can we do that? I mean, we are struggling to do that. I know that, but that would be a good kind of an objective for us to get into CII kind of a structure.
Certainly. we are doing more and more working with CII, for example, for exhibitions and programs we're organizing together. But your point is well taken. I think we need to do even more on that.
Yeah, because our voice should be heard there. So.
Yeah, absolutely. You're right. I agree.
You're 100% right, Upinder. In fact, as a body, FPSI is trying to draw closer and closer to CII to make use of their facilities, to make use of their reach, penetration, and their ability to lobby, which we don't do, for instance. So, but we will be working on that.
Okay.
Mr. Sesnath, sorry to interrupt. Just I forgot to mention. I'm really happy to listen, Mr. Rao, and definitely I have a huge respect for Mr. Ajim Premji. He's one of the change makers, and I think we need more of Mr. Ajim Premji to change the world from India. So I have a huge respect for him, and thanks for sharing the story with him, how to take India forward in the global market. Yeah.
Thank you. I'll very quickly summarize. It's running out of time. I won't take much time. The first thing is, of course, everybody mentioned large home market. It needs no emphasis. We have an outstanding example in front of us. Tractor industry, the largest in the world today, 950,000 tractors per year. Nobody comes anywhere near that. And these tractors, and how much is our export? Hardly 15%. So that's a huge amount of consumption. The same thing can be played out in infrastructure. And why is it required in infrastructure? Again, some figures. India is expected to be the third largest economy in the world with a GDP of $28 trillion by 2050. We are talking of 30 years from now. And that has to come on the back of manufacturing. Why? Because services, though they account for 55% of the GDP today, how much is the entire software industry population? 3 million. Just 3 million people out of 101.3 billion people account for 55% of our GDP. So where are we going to find? Agriculture is 18%. Manufacturing today is only 16%. So if the GDP has to grow from the present $3 trillion, if it has to grow to a figure of $28 trillion in 30 years' time, something has to change. That has to be manufacturing. So there is no way out, and otherwise in infrastructure. How did China grow? Somebody was mentioning about how, in fact, Mr. Rao mentioned, how did China grow so fast? Infrastructure, they pump money and money. So we have a large home market. We can exploit it very well. Build on that, as everybody mentioned, to move more into global sales. But when we grow into global sales, we need to set ambitious targets. More importantly, we have to build manufacturing capability. Every single person in the audience, every single panelist mentioned, we have to have product reliability, we have to have good technology, we have to have manufacturing processes which allow for consistency of product quality. And more importantly, logistics support has to come from through infrastructure development from the government. And everybody was also saying mindset. We Indians are very famous. When we say 25th of the month, we mean around the 25th of the month. We don't exactly mean 25th. We could do it on 24th. We could do it on 28th also. Do we give it in writing in stone that it's going to be done on the 25th? No. And this is something which most people outside India find it very difficult to accept. So we have to change that mindset. We have to have global benchmarking. Infrastructure is lacking, which we need to improve. There is massive potential, but the speed at which we work and the outlook that we have is slow. We need to improve on that. We have to have collective aspiration to work together as an industry body to facilitate the growth of the entire industry. Beautifully said and very well said. And we have to do it the right way in terms of having safety, product reliability, quality, and the right processes. More importantly, last but not the least, we have to invest in technology which is relevant and which is closer to the market. Whether it's an end user, whether it is for us, or whether it is for anybody else. It has to be closer to the market if it has to make a good difference. I thank all of you for sparing your time and sharing your ideas. I will be sharing all these points to the FPSI Secretariat, and the Secretariat will collate that into a summary and circulate to everybody. Because the idea in inviting all of you was to pick your brains. You're all the collective captains of industry, stalwarts. So we wanted to pick your brains for the benefit of the FPS Fluid Power fraternity. So we will be circulating this in a summary form through the FPSI Secretariat to all the members and of course to yourselves. Thank you so much for your thoughts. Thank you so much for your time. Have a good evening and have a good weekend, sirs.
Thank you. Thank you for a great job.
Thank you.
Thank you.
Thank you. Thank you. Thank you very much.
Back to you, Suresh.
My pleasure.
Thanks, Shesh, for organizing a great panel discussion. On the lighter side, maybe over the weekend, the numbers for next 5 years are going to increase by each of us. So Monday morning, all our the business plans are going to be quite high, I suppose, and it's going to keep our bosses happy.
Good observation.
Yeah.
Thanks a lot.
Yeah, thanks, Shesh.
Yeah.
So we move on to the final event before the vote of thanks. There is an interesting connect that's happening between the Fluid Power Society of India and International Fluid Power Society. We are trying to work with them and in giving certification for engineers, also for technicians, which is quite valid for the professionals as they move around both in India and abroad. So next on the session, we have a video recording. Unfortunately, we could not get the speaker, Donna Polander, live tonight. So we have a video recording from the FPSI on the 7th. And if you have any questions during the session, kindly put it and the Secretariat will come back to you. But do remember to give your contact details so we can get in touch with you. Yeah. Joseph?
Good evening, everyone. Thank you very much for allowing me to speak to your organization. Let me tell you a little bit about myself and IFPS. The IFPS was started in 1960 by a group of professionals interested in supporting the future of the fluid power industry and the ever-changing technologies involved. Since our first certification was released in 1980, the IFPS has become the industry leader in fluid power and motion control certification and training. We currently offer 15 certifications with another in development. As for me, I have been working in the fluid power industry for over 25 years. I joined the IFPS in 2002, and I've been their executive director since 2003. During my tenure with IFPS, I've gained knowledge of hydraulics, pneumatics, and the importance of their proper design, installation, and maintenance. I am responsible for the day-to-day operation of IFPS and the development of our certification programs. And I am very happy to be here today to speak with you and to be the first to wish you a very happy Fluid Power Professionals Day. Let me tell you a little bit about the certifications IFPS offers. So we have mechanic and technician level certification for mobile hydraulic, industrial hydraulic, and pneumatic. We also offer our connector and conductor certification. That's a hose and tube assembly certification. And each of those certifications requires you to take two separate tests, a written test and a hands-on job performance test. And then we have a specialist level test for hydraulic, pneumatic, and electronic controls. And those certification tests require just the written test only. And then we have our engineer and system designer certifications, and those certifications require some prerequisites, some certification prerequisites, as well as an application and committee approval. You also need to hold a degree in engineering for our engineer or proven design experience for our system designer certification. And then we offer our accredited instructor and authorized job performance proctor certifications. And those also require some prerequisite certifications as well as attending a workshop and committee approval. We have advanced level certifications, and how the advanced level certifications work is that you would obtain certain different certifications to get to that master level. For example, if you take that first vertical column, you would need to obtain your connector and conductor, your industrial hydraulic mechanic, and your industrial hydraulic technician certification to get to that master of industrial hydraulics. And, you know, as you can see from the vertical and horizontal paths, that you can earn several master certifications in our mechanic and technician level. We also offer the same for our specialist level, just for the hydraulic and pneumatic specialist. So if you obtain your hydraulic specialist and your pneumatic specialist, you're considered a certified fluid power specialist. So there are some benefits, obvious benefits, to obtaining an advanced level certification. One being that you're proving that you are familiar with fluid power technology, and you've been verified through a third-party vendor-neutral test. But the other benefit is that you save money when you go to recertify. So when it comes time to recertify your certification, you only have to recertify that advanced or master level certification, which can, if you have multiple certifications, can save a significant amount of money. So let me just give you some facts about our certification program. So as I mentioned earlier in my intro, our first certification was issued in 1980. We have about a little over 10,000 active certifications right now, but we've issued over 43,000 certifications since 1980. And so you might ask yourself, well, why aren't there 43,000 certifications currently active? And that's due to people leaving the industry, whether they retire, whether they decide not to recertify, whatever the case may be. But we have over 10,000 active right now. All of our tests, when they are developed, they are psychometrically evaluated. They meet defensible standards, so that, and what that means is if ever you're taken to court and you have someone who's certified on your staff that may have been involved in an accident or something, proving that you have someone certified through the IFPS allows that defensible standard. Our average pass-fail ratio for all of our certification tests is 70% pass, 30% fail, and it does vary a little bit from each certification. Some additional certification facts. All of our certifications are developed using industry subject matter experts. The staff does not develop the material that goes into the certification. We gather the best practices that are out there in the industry, really worldwide, to develop our certification materials. They're also written at a level specific to each certification. So we have study manuals or guides that help people to prepare for the certification, and they're written at the level that the certification is offered. And again, all the material in the study manual is defensible because we take it from industry best practices. All of the test questions are gleaned from our study materials. So in essence, if you really prepare by reading and studying the materials that we provide to you, you can obtain your certification on your own. You don't need to do any review training. So we also offer safety information. They're throughout each one of our study manuals. And then we also do have some safety test questions on each of the certifications. So some information that you might want to know, that our certifications are internationally recognized. We have given over 1,100 tests taken outside the United States. All of our certifications are portable. And what we mean by that is, even if your company pays for your certification, you own that certification. And if you work for one company and obtain the certification and you leave that company and go to another, then that's your certification to take with you. Certification review training, we do offer it virtually. I understand that the Fluid Power Society of India is working to have a certification review training program live there in India. So I'm sure that the people who run that organization will give you more information about that. But certification review training is optional, although it's very helpful to someone to prepare. And our written tests can be done almost anywhere in the world. The job performance tests are another story, and maybe we'll get into that in a little bit. So who certifies? Who have we worked with over the years to get certified? Well, we have fluid power manufacturers, distributors, OEMs, and users, and you all know that the fluid power industry really does span many different industries, from agriculture, mining, aeronautical industry. And so really fluid power touches many, many industries. So you can imagine that our industry is huge, because it's not just the small fluid power industry that we certify. So some of the, just to give you an example of some of the people who certify, there are major manufacturers, which I know you're all familiar with, like Rexroth and Parker Hannifin, Eaton, Sun, Danfoss, Bimba, SMC, Norgren. And there are many more manufacturers that certify, but these are some of the more popular names that you probably recognize. Now, some of these names you may not recognize, but there are hundreds of fluid power distributors that certify, particularly in the United States and Canada, but really all over the world. And these are just some of the fluid power distributors. You may or may not recognize those names. But I'm sure that you'll recognize some of these original equipment manufacturers like Caterpillar, John Deere, Volvo, Altec, Terex, Case. All of these companies have certified, particularly in the mobile hydraulic mechanic certification. And then, of course, end users, I'm sure you recognize some of the names on there, but the U.S. Army, Navy, and Coast Guard do certify, particularly, again, in the mechanic level certification, but we also have some engineers certified through the military in the United States. Boeing, of course, you know, I'm sure you've all flown on a Boeing piece of equipment. Verizon, in the United States, we have the Departments of Transportation that certify. But most interestingly, in the United States, 85% of all electrical utility companies in the United States certify mobile hydraulic mechanic, particularly those who use Altec equipment. So, you know, where have we offered those 1,100 tests that we've offered outside the United States? This is a list of where we have offered the tests. And this particular list is in order by the number of certifications that we have given. So obviously the United States is the most popular, in Canada, but Australia, India is number 4 in the list. So absolutely, we can get a certification test to you in India. We can work with you to arrange for that. It does need to be a proctored environment. So I'm going to focus a little bit on our certifications. First off, the specialist level certification. We offer a hydraulic, a pneumatic, and electronic controls, as I mentioned earlier. Again, it requires a written test only. It can be done online, as I mentioned, anywhere in the world. In particular, in the US, we still offer that pen and paper test. Each of the specialist level certifications have 50 questions. You are permitted to bring any copywritten bound materials into the test with you, references that will help you to answer the questions, but they must be copywritten and bound materials. You need a 70% to pass, or in other words, 35 questions answered correctly in order to pass the certification. We offer, when you apply for the certification, a free copy of our study manual. It's a PDF copy that you can download immediately upon applying for certification, but you may also purchase a printed manual that would be mailed to you in printed form. So our mechanic, technician, and connector and conductor certification, they're a little different. They require you to pass 2 tests, the written test which can be done anywhere in the world in a proctored environment, but also a hands-on, what we call a job performance test. Now, those are a little bit more challenging to get, but I'll talk about that in a minute. So again, same, you need to a 70% to pass. We offer the free electronic copy of the study manual, and again, you can purchase a print manual if you prefer that. The same with the written test for the mechanic and technician. Those are a little different than our specialists. These are 75 questions. Again, we offer it primarily in the United States, pen and paper, but online. You, again, can bring any written bound materials into the test, and you do need a 70% to pass, or in other words, answer 53 questions correctly. Now, the job performance test, it has 6 stations to it, and it must be proctored by an authorized proctor with an approved kit. We do have a kit in Australia, Western Australia, but we also have job performance proctors in the United States and Canada. And I have had some discussions with the powers that be at the Fluid Power Society of India to try to get a proctor in India and a kit in India. So that may happen before you know it, but you will be made aware of that when it does happen. So you may ask yourself, well, you know, why? Why should I certify? Why should I have the people who work for me certified? And the answer really is safety, 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 personnel safety. All of our certifications have integrated safety within them. And of course, we want the people who work for us and also ourselves to be safe. And knowledge equals safety. So, you know, you can see as I flash through these, we have safety tips throughout our certifications. Each and every one of them offers safety tips because, as I mentioned, and I don't think you can mention it enough, personnel safety is paramount over anything else. There are other reasons why you would want to certify. We believe that personnel safety is the #1 reason, but it also helps with downtime, uptime, the proper design of fluid power systems, you know, on and on. I'm sure your common sense would tell you why you would want to certify. So you'll ask, you know, yourself, what's the investment? What will it cost me to certify either myself or the people who work for me? So I'm going to give you a few examples. These are all in US dollars, okay? So if you want to certify as a specialist, a fluid power specialist, a hydraulic, pneumatic, or an electronic control specialist, you can purchase a membership, an IFPS membership, that is $75 a year. Once you are a member, you would pay $299 to take the test, $374. Okay, if you decide to not purchase a membership, it's $475. So obviously you save $100. Now, again, membership is not required. Certification review training is not required. So really the investment would be either $374 if you decide to purchase a membership, or $475 if you decide not to purchase a membership. Now, for the mechanic and technician and the connector and conductor, again, if you decide to purchase a membership for $75 a year, you would pay $199 for the written test and $160 for the job performance test. So the total is $434, but if you opt to not purchase the membership, it's $554. So obviously there is a savings there if you want to purchase a membership. So in the grand scheme of things, over 5 years, it's about $6 a month to be certified through the IFPS. But we do offer what we call commitment packages to companies, and we would offer the same thing through the Fluid Power Society of India. If the Fluid Power Society of India wanted to purchase commitment packages for their members, they can certainly do that. And they start at 10 individuals and go up to, you know, as many as you want. And obviously, the more people you certify, the bigger the discount. So this it ultimately is a big savings if you do commit to certifying a minimum number of people, which would be 10. So what is critical for success is preparation. Over the 20 some years that I've been managing the IFPS, I have learned that some people do not take the certification test as seriously as they should, and then they're not successful. So preparing for this certification is key. You do not want to set yourself or the people who work for you up for failure. So again, as I mentioned before, you know, we don't require any specific prerequisite. You don't have to have a number of, you know, years in the industry. You don't have to take a class or a course or a review training session, but you do need to prepare. These tests are not easy. They are pretty high level tests, but we do offer you the perfect solution to that, and that is our study material, our study manual. If you prepare by reading that manual and really getting to know the material in it, you can be successful. Obviously, you know, reading a flat book may be difficult for you. There may be concepts that you're not quite sure about, and that's where certification and review training comes in handy. And I'm going to go over in the next several slides some things that IFPS offers that can help you to prepare. As I mentioned, I know that the Fluid Power Society of India is working toward having a review training session for you that would help you to prepare for certification. So, as I just mentioned, IFPS offers many tools for your successful certification journey. The first would be, as I mentioned before, the self-study, that very top bullet item there. Our study manuals are the #1 tool that we offer. The second would be some interactive study manuals, and these are online, done at your own pace. Currently, we offer them for the hydraulic and pneumatic specialist only. So just to give you some more details about that, as I mentioned, it's at your own pace. We have circuit schematics that are color-coded, animated. They have voiceover, give you a description, and I'm going to go into that a little bit as well. We have full-color graphics in our interactive study guide, and we have chapter review questions, and they're interactive. So you get through a chapter, and we ask you a series of questions. And if you answer the series of questions correct, then you know you've grasped the information, you've mastered that chapter, and you can move on to the next chapter. So it's quite nice to have this at your own pace. It's all voiceover, so you will hear an instructor explaining the material that's in the study guide to you. So if you're an auditory learner, it helps to hear the material, then this really would be helpful to you. And then we also offer 3 additional online pre-tests within our interactive study manuals. And I'm going to get into what our online pre-tests are in a few minutes. And then it also contains some additional video and explanations that are not covered in the printed manual, really kind of going into more detail about it. As I mentioned before, the printed manual covers everything that's on the test, but the interactive study manual goes into a little bit more detail. So once you purchase the interactive study guide, you have it available to you for a year. It's $349. And if you want to purchase a number of them for people that work for you, we do offer bulk discounts. You would just contact me about that. Okay, as I mentioned earlier, our color-coded circuit schematics that are animated, they're integrated into our interactive study guides, but we also offer these animated circuits as a separate product that you can purchase on our website and download immediately. So I will, right now we have 37 hydraulic circuits, 7 that are specific for mobile, and then we offer 14 pneumatic circuits. And again, you can purchase a flash drive, but right now it's just so easy to download the whole package. Once you purchase it, it's available immediately to you in your account on our website. So here's an example of one of our hydraulic circuits.
Pressure reducing circuit in idle position. Shifting Retracting the directional valve exposes both cylinders to the pump flow. The cylinder with the lightest pressure requirement extends first. When the cylinder with the pressure reducing valve bottoms out, the max pressure will be less than the system pressure on the other cylinder. When both cylinders are stalled or bottomed out, the main relief opens to limit the system's maximum pressure. When retracting, nothing controls which cylinder would retract first other than their load conditions.
Now, here is an example of one of our mobile hydraulic circuits.
The circuit shown represents the boom and bucket cylinders and their associated valving. The circuit is supplied by a fixed displacement pump with a main system relief valve set at 21 MPa, 3000 psi. The flow is supplying two directional control valves with a closed center, which respectively supply the bucket cylinder and the two boom cylinders, allowing them to be extended or retracted as necessary during operation. Each cylinder in the circuit is equipped with circuit work port reliefs set at 22.5 MPa, 3250 psi, which only come into operation if the machine is overloaded and the directional control valves are in the center position. In any other position of the directional control valves, the main relief would actuate instead of the circuit work port reliefs. Each directional control valve is equipped with a load drop check valve, which is used to prevent the load from settling during the transition of the different valve positions. The bucket cylinder is also equipped with anti-cavitation check valves plumbed in around the circuit work port reliefs. The typical operation sequence of this circuit is that the bucket cylinder is retracted to secure the load in the bucket. Let's watch the circuit as it is set in motion. The boom cylinders are extended as necessary to obtain the desired height of the bucket. The bucket is then dumped by extending the bucket cylinder. As the bucket goes over center, gravity will try to pull the cylinder rod and piston ahead of the pump flow being supplied, and the cap end of the cylinder may try to cavitate. The anti-cavitation check valves allow flow from the reservoir to fill the cap end and prevent cavitation. Transisting with the bucket full and raised may cause load-induced movement of the bucket, bouncing, which would possibly cause either side circuit work port reliefs to actuate, and the anti-cavitation check valves would supply the necessary makeup fluid to the opposite side.
As you can see, they're very detailed animations, very helpful for people to understand how specific circuits work. And again, we offer these on our website. So it's a flash drive or it's also a download. But they include the animations themselves that you saw the animation, the voiceover animation, which I just showed those to you, and then detailed circuit operation information. So each of these, again, can be purchased on our website. The 37 hydraulic circuits are available for $199, and that includes the mobile. If you wanted to buy the mobile only, the 7 circuits are available for $75, and then the 14 pneumatic circuits, which I didn't give you an example of the pneumatic circuits, but we do have 14 of those, can be purchased for $149. But all of those are integrated in our interactive study guides. So going on, additional tools for success. I talked a little bit about certification review training, and IFPS does also offer certification review training online. So we could do that for you in India. We wouldn't send an IFPS accredited instructor to your location, but we would do it online on a customizable basis. So if you would prefer that you did 2 hours, 3 days a week, or whether you did, a concentrated 8 hours a day for 4 days, whatever it is that you want, we can certainly customize an online certification review training package for you. It is English only, as our tests are all in English only. They are a combination of imperial and metric units. So I just wanted to make you aware of that as well. Now, I had mentioned earlier about our pre-tests. So the pre-tests are a terrific tool to help you to measure whether you're ready to take the test. We offer one free pre-test online, but all of our study manuals have 3 or 4 pre-tests in the back of the book. But the online pre-test can be done right from our website. Now, this video goes pretty quickly, so I'll play the video, but you can see where you can locate our pre-tests on our website. You can see exactly what you'll need to do to take the pretest. You need to fill in your name and your email address. And this particular pretest is for the pneumatic specialist. As you can see, I made the video go much more quickly, but there are 18 questions and you're given 1 hour. So that's really a good measure of how the test will go. So obviously this is 1/3 of the test questions on a specialist level, and you get 1/3 the time. So if you take these 18 questions and you pass, then you know you're ready to take the certification. If you take this pre-test and you fail, then you know you'll need to do a little bit more study. But as you can see on the screen there, it will tell you whether you got the question right or whether you got the question wrong, and then what the correct answer will be. So it's a really nice little tool to help you to measure whether you're ready to take the test or not, and give you the feeling of what it would be like to take our online tests. And then we also offer what we call core competency reports, and this is when you take the test. And we offer these reports whether you pass or you fail the test. But if you fail particularly, it gives you an idea of where you need to go back to study. So again, it'll tell you what you've earned. Obviously, this person earned 41 points out of a possible 50. So they got an 82%, they passed. But as you can see on the bottom there, it tells you, sorry about that, exactly what areas you got specific grades in. So, this person did very well, but the section where they didn't do as well as the others would be the analyzing and the troubleshooting of hydraulic systems. Now, if you would have failed your test and you would have maybe gotten, say, a 60 or a 50 in a specific area, then okay, I want to retake the test. I need to prepare particularly in that section of the study manual. So I think they're very helpful. And again, we offer a plethora of books, technical training, technical workshops, online training. We offer many free web seminars, so I highly encourage you to become a member of IFPS, and then all of the web seminars are offered to you for free. We have, I think there are something like 100 already pre-recorded that that we've been doing for the past 10 years. So just having those industry expert web seminars is a terrific value for the $75 that you would pay to become a member of IFPS. But we do offer our very recent release, our Fluid Power Reference Handbook. I'm going to play a little video, a promo video about our Fluid Power Reference Handbook. We've sold over 1,000 copies of this book in less than a year. We continue to sell them every day. It is what we think is a must-have. So I'm going to play a video showing you a little bit about our Fluid Power Reference Handbook.
You haven't purchased your copy of the latest must-have reference handbook for the fluid power industry? What are you waiting for? What you will find in this handbook is everything a fluid power professional needs right at your fingertips and in living color. The full color index coordinates with section tabs on each page, making it easy to find the information you're looking for in this 380-page ultimate resource. Sections include safety, symbology, fluid power data, fluids, fluid conditioning, connectors and conductors, reservoirs, compressors, prime movers, valves, cylinders, motors, semi-rotary actuators, vacuum, accumulators, control theory, troubleshooting algorithms, pumps, and a glossary of terms. Don't wait. Order your copy today. Discounts are available for 10 or more books, and as always, IFPS members receive a discount. Visit www.ifps.org to order your copy today.
So as you can see, it's a very comprehensive a reference book that we think that anyone who works in the fluid power industry should have. So that's all I have for you today. I'm sorry that I couldn't be there live in person, but if you have any questions, we have a lot of answers on our website, ifps.org, or please feel free to email me at dpollender@ifps.org. It's right there on your screen. I'm happy to answer any questions you might have, and I thank you sincerely for allowing me to present to you today and talk about something that's very passionate to me, and that's fluid power, and particularly fluid power certification. Again, I want to wish you a very happy Fluid Power Professionals Day. Have a wonderful evening. Thank you very much.
Yeah. Are we live? Okay, thanks. Thanks to Donna from International Fluid Power Society for sending this recording. Thanks also to Joseph and the digital team for putting this across. Now we move on to the last session. Over to our General Secretary Srinivas Gutikar to give the vote of thanks. Our vibrant, energetic taskmaster. So over to you, Srinivas.
Hey, thanks, Suresh. Thanks for that. It's a great honor and privilege to propose a vote of thanks on this memorable occasion. Let me first and foremost thanks to our Pascal awardee, Dr. S. Karunanidhi. Very big congratulations and thanks for his contribution to the Fluid Power fraternity. I think he put a nice presentation and thoughts. I still recollect the analogy he gives between the gods and the product life cycle, and it was really nice to look at it. Like great attitude, gratitude, wonderful and wonderful. It is really nice. Thank you, Mr. Dr. Karunanidhi. Next, moving on to the next awardee, MS Weiser. I still miss him. I've worked him past 4 years. I still, it's like yesterday, every event later, we used to have a chat almost like 1 hour. We can't forget him. He is there in our minds and soul. It's great to work with him and we miss him a lot. Thanks to Vikram to be participating in this occasion and accepting the award posthumously for MS Weiser. We also thank all the industry leaders, Mr. Chandar Alam, Mr. R. Joshi, Mr. Upinder Azan, Dr. Deepak Methi, and our favorite Mr. Sitapati Rao, and the best moderator, I can say, the Sheshnath. The messages goes on like session can be sessions. So that's how he moderated. He moderated very well. I still remember that when I entered 20 years back, the fluid power or hydraulics, I thought how big it is. So because of I'm being from Belgium, it is polyhedron was the first and the last industry. That's how I can say. That's how it started with me in 20 years back. And then now I see it, it's like 20 years later. There's a huge opportunity. We are talking about going top 5 manufacturing hub for fluid power. And that day, which I made a choose, fluid power, it's still as a passion, stays with us. I still recent like 2019 FPPD event where Mr. Prahlad Dabolkar told we're all Pascalites. So we also have some part of hydraulic oil in our bloods. So our passion takes us continuously with fluid power. Thanks for the panel discussion and all the panel members. I would like to put my gratitude for Mrs. Donna Pollander, even though she couldn't participate today in person. However, she made a point to record the whole session and share with us specifically for this event. My heartfelt thanks to our colleagues, council members, chapter members, FPSA members, non-members who supported to make this event a great success. I owe a special gratitude to all our sponsors, Platinum and Gold, and speakers at FPTS. We still say 1 universe, 9 planets, 194 countries, millions of islands, and 7 seas. However, in this virtual new normal, all are in the same platform. In this time, I remember a quote or a book saying the world is not round, it's flat. So I would like to put special appreciation and thanks to digital support team, partners like Benjamin, Rahul, and their team, without which we couldn't have made this virtual connect smooth. I would like to thank our Secretary Joseph, where he worked almost like more than 16 to 18 hours last 3-4 days, and even though during these tough times of pandemic, lockdown, and other thing in Bangalore, he showed his commitment and traveled to the digital studio, ensured the event is run smooth. And background, Elizabeth, Secretary, she managed and supported very well this event with Joseph. Thanks to Elizabeth also. Once again, I thank all for your attention, and I also thank today's moderator, Suresh Kandan, energetic fellow, and always my friend. Thank you very much. Over to you, Suresh.
Thanks, Srini, for summarizing everything and giving the word of thanks. So we're coming to the end of FPPD 2021, but it's going to be the beginning for more events to come as the coming months and year. We have a lot of things planned in the National Council as well as in the regional chapters. And just for the information of everybody out there, in 2 years, we're going to be 50 years. So it's going to be a grand event. So a lot of things happening there. You also have the certification that's going to be on. So your connect to the whole thing will be the FPSI office, the secretariat. So do remember to register as a member, which makes you connect to all these things. Whoever is not registered, kindly register, and let's keep moving ahead and be inspirational like we listened today to the panel of discussion. Jai Bharat, Jai Hind from the FPSI team. See you then. Bye-bye.
Thank you. Thank you. Very well done.